Hey, I want to show you something. Let's take a little trip off of Earth and park our spacecraft somewhere near the moon. We're now almost 240,000 miles away from our home planet. That's almost 100 times the width of the United States. Now we've brought a special set of tools with us, a giant hammer and an enormous chisel. Place the chisel at the Earth's North Pole and strike its head with the hammer. The Earth cracks open like an eggshell and we see another planet. This is Thea, and it's hiding inside our planet like a yolk in an egg. If you want to find out how it got there, you'd need to travel back in time 4.5 billion years. This beautiful nebula is what will eventually become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Over time, this jigsaw puzzle of debris becomes denser and heavier. The temperature inside the giant is rising. Soon, it gets so high that it'll trigger a nuclear chain reaction. One more second, and bam! There's an explosion so powerful that the shockwaves travel far into deep space. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. But we're interested in that small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core while the oceans of lava are gradually cooling down. But some millions of years later, after the Sun's birth, you notice another small object. Here comes Thea. This small planet was formed at about the same time as Earth, and right now, it's following a crazy spiral trajectory at enormous speed. Scientists believe Thea was like a ball Jupiter and Venus played around with. Venus would pull Thea in one direction, and then Jupiter would pull it right back. But what makes up 99.8% of the mass of the solar system is the Sun. It's what makes Thea move into almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Thea is roughly the size of Mars, as wide as the Atlantic Ocean from New York to Portugal. At this point, the collision can't be avoided. Thea is traveling towards Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If this smaller planet would crash into Earth at a particular angle, Earth would most likely be torn apart, as well as Thea itself. The collision would cause a huge blast visible on other planets, even on a bright day. Nothing would be left but some burning dust and debris. Even if Thea only slightly grazes the Earth, it'll still knock out a sizable chunk. But the collision with Thea happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shockwave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site, which soon gets filled in with boiling lava. The remnants of Thea and the ejected fragments of Earth begin to orbit our planet. According to one theory, these fragments actually form two moons. At first, they travel together, but one day they get too close to each other and collide, forming one large space body. The other theory claims that all the loose shards get pulled in by the remnants of Thea, and that sometime after that, they form the moon, as we know it today. At this point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Thea that we have different seasons and 24 hours in a day. Now, Earth also has these things called lithospheric plates. These are enormous solid land masses that make up the crust of our planet. After the collision with Thea, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet. So Earth gains a kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over the next nearly 4 billion years, simple single-cell organisms evolve into the kinds of complex life you see today. According to scientists, a collision like we had with Thea is a very rare event. The probability that somewhere out there there's a planet like ours that has survived the same catastrophe is even rarer still. This may be the reason why we have yet to find other traces of other civilizations out there in space. Meanwhile, The remains of Thea are still here on Earth. Of course, it doesn't look like an actual entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see two huge lava blobs the size of large continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Thea. They didn't mix with the Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise these lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Thea might be on the moon. The Apollo space missions brought back many soil samples for analysis, which led scientists to conclude that the moon is very similar to the Earth in structure. Someday in the future, people could drill deep down and take samples of the moon's crust. Then they'd analyze the blobs from Earth, and if their structure matched, it would be undeniable proof that Thea did hit Earth 4.5 billion years ago and gave us the moon. But for the time being, Thea remains an unsolved mystery. Scientists are still not sure that the planet actually existed. The whole idea does perfectly fit the model of the moon's creation, but it's also possible that this incredible collision may have never happened. Now, let's travel 41 light years away from Earth to the planet 55 Cancri e. It's about twice the size of Earth and 8 times heavier. Let's take out our giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than on Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon, and the structure changes. First, it turns into graphite, but then add just a bit more pressure, and the graphite turns to diamond. On Earth, diamonds form at depths 60 miles below sea level, where the pressure is 50,000 times greater than that on the surface. And the temperature there averages over 1,000 degrees, which is as hot as fire. Diamonds are often ejected closer to the surface in volcanic eruptions, but still, people mostly have to dig mines 1,500 feet deep to find these beautiful gems. Currently, the Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now, imagine a diamond the size of an entire planet! Now, let's fly back to our solar system. Our destination now is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% of the mass of Earth. Its surface is enclosed in an icy crust that's about 19 miles thick. Europa is completely covered in water. It's freezing here, 3 times colder than that of the North Pole and Earth. The water turns to ice almost instantly, but the ocean beneath the surface is still liquid. Europa has a gravitational relationship with Jupiter, just like the moon with the Earth. This creates tidal forces that heat Europa's core, which then melts the ice around it. The result is a huge ocean, 2 or 3 times larger than that of Earth's oceans combined. Scientists believe that water is one of the essential ingredients for life. This means that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans, though the water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria could live there. Europa is almost the same age as Earth, so there has been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They might be building big cities and dreaming of conquering space. But for now, all we can do is speculate, and maybe someday send a probe to Europa to find out if life is possible there.
TRES 2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES 2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, There are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, well, I'm not going to say that again, is the only exoplanet in the orbit of its star. And at first glance, it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not irregular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler 70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler 70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP 12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP 12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that somewhere. Still, if it has a rocky core, it might generate some heat, So there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Carrot Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Carrot 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Carrot 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. What would happen if our planet turned into 2 separate ones, one consisting entirely of land and the other one of water? Could we survive on any of them, and how? Well, you're lucky, because I'm going to answer this question right now. So let's imagine that our Earth has turned into 2 separate planets sharing one orbit. Let's call these hypothetical planets rock and water. I know, very original. Anyway, let's start with the rock, because this one is much easier to imagine. All we should do is ask, what would happen if all the oceans on the Earth suddenly dried up? Now, we know that water is life. It covers 70% of the surface of our planet. There's so much water that even if all the oceans and seas disappeared, some of it would still be left in underground rivers, streams, and so on. But unfortunately, it would not be enough for us to survive. All sea creatures disappear. After some time, all other animals, plants, and of course, people share their fate. Completely dried forests burst into flames sooner or later and burn until there is nothing left but ashes. But hey, it's not that bad. Well, it is bad, but life can still exist in some form. There are some bacteria that make cockroaches jealous. They're able to survive absolutely any conditions. For example, extremophiles have already evolved to live without water. These little guys can survive in an incredibly hot or acidic environment without water or even sunlight. Without them, the rock becomes an empty, lifeless planet. Although, who knows? Maybe someday extremophiles will be able to evolve into some wildly cool forms that can survive literally anywhere. But for now, the rock is just a floating rock, basically. Oh wait, did you imagine a hot desert or some sort of red-hot steppes? Surprise, surprise! This planet is actually extremely cold. You see, without water, there would be no atmosphere. The atmosphere consists of a concentration of various gases, including hydrogen and oxygen. Some H and O, you know where this is going, right? Yep, no water, no atmosphere. And since it is the atmosphere that accumulates all the heat we need, the planet would be very cold without it. The contrast between cold and less cold places also becomes very sharp. You see, water is basically a climate stabilizer. The oceans absorb almost all of the heat of our sun. They distribute it evenly over the Earth to make sure it doesn't get too cold or too hot. So without it, the rock gradually turns into a cold desert. The average temperature on this planet is around minus 100 degrees Fahrenheit. At both poles, the temperature is extremely low, about minus 300 degrees. And even in the warmest places, it doesn't exceed 20 degrees. These warm places are now the former oceans because their dried up depths are located much closer to the hot core of the planet. Wait, I hope you don't imagine this planet as covered in snow either. We don't have any water at all, remember? It's just a very cold rock. At this point, we're just a bigger and browner version of the moon. The moon is basically a waterless piece of Earth after all. But hey, what happens to volcanoes? They're basically our last hope to stay warm, aren't they? Unfortunately, volcanic activity is decreasing due to a lack of water. You see, volcanoes and their eruptions happen because of the collisions of two tectonic plates, the oceanic and continental ones. The weight of the water presses on the oceanic plates. They go under the continental plates and form volcanoes. So if there's no water weight, then there's no volcanoes and volcanic activity drops significantly. The rock now is just a planet full of many incredible high mountains. And every time the tectonic plates collide, they form more and more of these mountains and trenches, including some very big ones, like the famous Mariana Trench. I would say, be careful not to fall, but hey, there's no one to fall there. So? Also, there's no weather anymore. No water means no more snow, ice, or rain, or even clouds. The wind would probably be quite strong, though. Well, that's the fate of the planet rock. Not very bright, so let's just go see how the water planet is doing. Many, many billions of years ago, I wasn't around then, our Earth actually was a planet entirely covered with water. Then, about 1 billion years ago, the sea level dropped, the land appeared. This has changed the atmosphere of our planet forever, and that's how life was born here. But what happens if it returns to its original state? Well, to answer that question, we should first learn more about the ocean planets. So, what does one of these look like? Oh, sorry, I almost forgot. We have no idea. We haven't found any planets of this type because they're incredibly rare. I mean, there is one planet that is low-key and could be called an ocean planet. Yeah, I'm not even going to try and pronounce that. Still, even this one doesn't look the way you probably imagine. The water on it is in a very weird, unique state. Scientists have called this hot ice or superliquid water, and we've never seen anything like this before. In general, though, the actual ocean planets are very hard to find due to many physical reasons. These planets require very specific temperatures, pressures, and so on. But alright, just hypothetically, what would such a planet look like? Well, first of all, of course, it cannot be made entirely of water. I hope you didn't actually think that there could be just some gigantic water blob spinning around a star. It should still be a planet with a core and some kind of foundation. So let's just imagine that all the water on the former Earth has mixed into one giant salty ocean. Wow, that would be a dream come true for the sea creatures, but not for the rest of us. The only animals that could survive in this situation, except fish, are probably the birds that can swim and feed on fish. Now, I think even if the sea level rose significantly, at least a couple of islets could still stay above the water. Such islands would be the former peaks of huge mountains like Mount Everest. So if these birds build their nests there, they can even survive for some time. But what about you and me? Well, we still have a chance. If we had enough time to prepare for the huge flood, we could stay safe either in giant submarines or on giant ships. We can grow food on board and fish from the ocean. But without the Everest Islands, we are unlikely to last long. If something breaks and we have nowhere to dock, we won't be able to fix it. Unfortunately, we no longer have drinking water. Now we can get it only from rain or by filtering seawater. But we have to store it someplace, right? And all these water containers would take up a lot of space and be very heavy. But in general, planet water is not as bad as it might seem. It's quite warm. The average temperature here is about 50 degrees Fahrenheit. And the gap between the lowest and highest temperatures is minimal, from minus 20 degrees at the poles to 70 degrees at the equator. Compared to planet rock, this ain't bad at all. Planet water would also be slightly larger than the Earth in radius due to the volume of, yes, water. The density of this planet would be, on the contrary, quite low. The gravity could become a bit weaker too. Now, as for both planets, if we place them in the Earth's orbit, after some time they would still move away from each other and follow different trajectories. They would have aligned themselves not to collide with each other. On one of them, the year would last 12 months, and on the other one, 10 or 11. And that's about it. A fun fact: all of this can actually happen in the future. First of all, the Earth's crust is gradually becoming thinner. Hey, I like thin crust. On my pizza. On my planet, not so much. So, one day, water can really flood our entire land. On the other hand, in a couple of billion years, when our sun begins to expand and turn into a red giant, all the oceans on our planet will really dry up. Alright, take a deep breath and shake it out. That's enough of this grim fairy tale. It's a waste of time to worry about such things so far off when, today, I can't find my wallet anywhere. I thought I put it over here. Okay, here you are, in the middle of the ocean. It's endless, but you can't see it, because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans. Its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface. But if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214. An unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, It's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? Alright, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves.
Recently, scientists have made an astounding discovery that can change the entire course of Mars exploration. Apparently, there are oceans of liquid water on the red planet, so the future looks bright. We could use this water to support future missions, and then even relocate to Mars, since we wouldn't need to worry about where to get this precious liquid, right? Well, there's one big problem. These oceans of liquid water are in Mars, so deep inside that we aren't likely to get there. At least that's what a new analysis of seismic data collected by the Mars InSight lander claims. Huge reserves of liquid water seem to be the best explanation for some seismic quirks of the red planet. So all this precious water is out of our reach. But we need to find it to solve the puzzle of the aquatic history of our blushing, dusty neighbor. And the first thing we need to do is identify where the water is and how much of it the planet is hiding.
Navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
Now, our rovers are scurrying about on the surface of the red planet, gathering all the available data on the planet's surface geology. And it's getting increasingly obvious that Mars was once covered with water. Many factors, from Martian terrains to ancient dry lake beds and deltas, suggest that there was a time when the planet was quite soppy. These days, there's still some water on and right below the surface of Mars, but it's in the form of ice and nowhere near what Mars had in the ancient past. To understand how much of it could have been on the red planet billions of years ago, we must know where all this water went. There are two spots where the water could have gone: into space or toward the interior of Mars. Then it could have been isolated as either liquid reservoirs or ice deposits. Currently, we don't have any way of measuring how much water once leaked away. But now, we finally can find out more about the gooey center of the red planet. All thanks to the Mars InSight lander. It isn't operating anymore, but from November 2018 to December 2022, it was listening to the hums and rumbles and monitoring the activity below its feet. The thing is, acoustic waves generated by seismic activity deep inside the planet can change according to the composition and density of the material these waves are moving through. And scientists can get a lot of information analyzing the behavior of seismic waves. In this case, they used a model similar to those used to map underground oil fields and aquifers on our home planet. Then, with the help of this model, they analyzed the data gathered by InSight on Mars. They discovered that the best explanation could be that there was a layer of fractured rocks whose cracks were filled with water deep under the surface of the red planet. That layer could be at a depth of 7 to 12 miles. That's why it would be extremely tricky for future missions to get to it. And still, the new discovery could help us understand the Martian water cycle. Confirming the existence of a large reservoir of liquid water can help us sneak a peek at what the climate on Mars used to be or what it could be like one day. And if once Mars had a lot of water, it could have been habitable in the ancient past and might become habitable in the future. Water is crucial for life as we know it, so underground water reservoirs on the red planet could already be habitable. Maybe, while we're talking, tiny microorganisms or even some tentacled creatures are living their lives in the comfort of their underground home. On Earth, super deep mines do host life, and the bottom of the ocean, with its immense unbelievable pressures, isn't lifeless either. So far, we haven't found any evidence of life on Mars, but for now, it sounds like this place has the potential to sustain life. InSight data has shown that there isn't likely to be a lot of water ice in the upper crust of the planet, at least in the region around the lander. But if it turns out that there is a water-rich layer deep below the surface and stretching around the entire globe of the planet, then there would be enough water to fill ancient ocean beds and even more. Now, Mars isn't the only place outside Earth where there is water or where we might one day find water. Take the good old Moon, for example. On Earth's natural satellite, water can be found all over the surface, but it's not the water you might be imagining. On the Moon, water remains mostly as ice, and it's distributed unevenly. For example, the poles of the Moon are the regions that never receive sunlight. This is the reason they're extremely cold, and it's no wonder there's a lot of ice there. The ice in these areas is often mixed with the lunar soil and hiding deep below the surface. Then there's Enceladus, the sixth largest moon of Saturn. In reality, it's not that large, just 314 miles across. In other words, this moon is small enough to fit inside Arizona. Ooh, we should try that. Well, interestingly, when the Cassini space probe first arrived at Saturn, researchers were expecting Enceladus to be a frozen ball of ice. But what they saw was plumes of icy particles and water vapor erupting from geysers on the moon's surface. It was clear that there was a massive ocean between the moon's rocky core and its icy shell. Then there's Jupiter's moon Europa. Scientists think that this world is one of the most promising places in the solar system when it comes to searching for new life forms. That's because Europa has a huge saltwater ocean as deep as 40 to 100 miles. And even though it's under a layer of ice that is likely to be 10 to 20 miles thick, it's still potentially habitable. Astronomers believe that plumes of water might erupt from cracks in the ice shell and release the contents of the moon's ocean into space. The temperature, pressure, and chemistry are very different on Europa, and astronomers aren't sure yet how the ice behaves there. That's the main reason they haven't figured out yet how deep or large the water reservoirs on Europa are and how long they need to refreeze. But out of all the places where we could find water in the universe, the most bizarre is probably open space. In 2011, two teams of astronomers discovered a cloud of water floating freely among stars. It was the largest and farthest reservoir of water ever detected. So this massive cloud of water vapor surrounds a black hole. But not just any black hole. This one's a quasar, located 12 billion light-years from Earth. The conditions around this quasar must be really special to create such an enormous amount of water. This cloud contains 140 trillion times the volume of all the water on Earth. That's enough to give every person on the planet a whole planet's worth of water 20,000 times over. Sounds wild, doesn't it? But there's something even cooler. Astronomers think this water cloud formed just 1.6 billion years after the universe began. This discovery is yet another sign that water has been around all over the universe, even in its early days. But here's the kicker. Until they found this, scientists had never detected water vapor so far back in time. Sure, there's water in our Milky Way galaxy, but most of it's frozen solid in ice. This discovery really pushes the boundaries of what we know about water in the universe.
How do people usually describe planets? Massive, freezing, boiling hot, seismically active. Let's admit it, shiny is not normally on the list. Unless we're talking about a world called LTT 9779b, which might be the shiniest planet we've ever seen. This exoplanet, which is basically any planet outside our solar system, is ultra hot and acts like a giant space mirror because it's covered with a thick layer of reflective metallic clouds. This unusual world is located about 264 light-years away from our planet. And the most amazing thing about it is that it reflects approximately 80% of all the light its parent star sends its way. For comparison, Earth reflects a mere 30% of the light it gets from the Sun. The bizarre exoplanet is even more reflective than the shiniest planet in the solar system, Venus, which reflects around 75% of sunlight due to its thick clouds. LTT 9779b is 5 times as large as Earth, which makes it the largest space mirror ever discovered. By the way, this world was found by NASA's Transiting Exoplanet Survey satellite mission in 2020. But the highly reflective nature of the planet was uncovered later thanks to a follow-up investigation conducted by the European Space Agency Exoplanet Hunting Spacecraft, CHEOPS, which stands for Characterizing Exoplanet Satellite. Now, imagine a planet the size of our ice giant Neptune. It's a burning world floating close to its star. If you stepped on its surface and looked up, you'd see heavy clouds of metals floating over your head, raining down titanium droplets. The planet's size, coupled with its insane temperatures, allow astronomers to classify the planet as an ultra-hot Neptune. Now, a planet's high reflectivity is a quality known as albedo. And in the case of our shiny world, its albedo mystifies scientists. All because most planets that are not ice worlds, or planets with thick layers of reflective clouds like Venus, normally have low albedos. Their atmosphere or surfaces simply absorb the light coming from their stars, preventing it from getting reflected back into space. And initially, researchers were sure that LT9779b would have a low albedo. After that, by no means was it an ice world. Not with the surface temperatures reaching 3,650 degrees Fahrenheit on the side of the planet permanently facing its parent star. It was supposed to be too hot for water clouds to form. Even clouds of metal or glass wouldn't be able to form in such a scorching climate. Astronomers expected a planet like that to have its atmosphere destroyed by its star, which would leave behind a lifeless, rocky world. That's why discovering metallic clouds was so unexpected. Of course, researchers were eager to find out how such clouds could have formed. It had remained a mystery until they decided to think about the cloud formation in the same way as condensation that appears in the bathroom after you take a hot shower. There are two ways to steam up your bathroom. You can cool the air until the water vapor condenses, or you can keep hot water running until clouds form. It will happen when the air in the bathroom becomes so saturated with vapor that it won't be able to hold it anymore. So, researchers came to the conclusion that most likely the atmosphere of the shiny planet became oversaturated with silicate at one point. And then, metal started vaporizing due to boiling hot temperatures on the permanent day side of the planet. But if you think that the reflective nature of LT9779b is its only unusual feature, you might want to hear this. The exoplanet is an example of an extremely rare planetary type, and ultra-hot Neptune. Astronomers have been searching for such planets for decades, but those preferred to remain a mystery. The fact that the planet survived so close to its star might be linked to its high reflectivity. Some experts believe that the metal clouds covering the planet probably reflect light and prevent the planet from overheating and evaporating. Plus, such a highly metallic atmosphere is much heavier and harder to blow away than any other. Now, about 850 light-years away from Earth, a planet called WASP 121b orbits its star. This planet is a hot Jupiter, which means it's a gas giant moving very close to its star. And because of such a short distance, the planet is also insanely hot. The average day temperature there is around 5,000 degrees Fahrenheit. Interestingly, just like our previous shiny world, this planet also has metallic clouds floating over its surface. But that's not the only oddity. WASP 121b has a bizarre oblong shape. Can it be because the planet is tidally locked to its star? It means that one of its sides always faces the star, while the other is always turned to the darkness of the cosmos. In other words, it's always daytime on one side of the planet and nighttime on the other, which causes crazy temperature differences. Researchers think it might be the reason for the metallic clouds. The water cycle on WASP 121b is also pretty bizarre, to say the least. On the illuminated side, the atoms that make up the planet's water get ripped apart by the insane temperatures. After that, they get blown by winds moving at 11,000 miles per hour to the other side of the planet. There, much lower temperatures allow the atom to recombine into water molecules. At the same time, the nighttime side is cold enough for metal clouds consisting of iron and corundum to form. When these clouds migrate to the daytime side of the planet, they vaporize and rain down metal on the planet's surface. But If these clouds don't seem impressive enough, I've got more. Astronomers predict that the planet will rip itself apart in the next several million years because of its incredibly fast winds and wild temperatures. Plus, the gravitational pull of the planet's parent star also plays its role in this dark prediction. Since WASP 121b is so close to the star's gravity pulls the planet into a weird oblong shape and makes gases like iron and magnesium leak from the planet's atmosphere. This pull is so strong that the planet is always on the verge of a tidal disruption. If it ever happens, the planet will come apart for good, metallic clouds and all. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists got some proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. Another planet you probably shouldn't set foot on is WASP 76b. There, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit larger than Jupiter in terms of size and is located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between the planet and its parent star is 10 times shorter than the distance between Mercury and the Sun.
Imagine swimming in a salty ocean deep beneath the icy shell of a moon. There are geothermal vents around you, and they provide the energy tiny microbes need to survive, or exploring a moon covered in rivers of methane and ethane, where life could be hiding in the depths of craters. The point is, we may not need to leave our own solar system to look for any sign of life outside of Earth. Icy moons could rewrite cosmic history with oceans sandwiched between an ice crust and a hot planetary core. Something unexpected happened in 2005. While visiting Saturn, the Cassini spacecraft flew through a fine water mist. It was spraying into space through cracks in the surface of Enceladus, one of Saturn's moons covered in ice. And the water was coming out at a crazy speed of 802 miles per hour. Cassini wasn't built to sample water, but it was still encouraging for scientists to discover something like that. They developed new missions where they wanted to focus on the icy moons of the outer regions of our solar system. On our home planet, water is the base for life, as we know it. And now, at least 6 moons might be spots where we could find watery oceans. 1 orbiting Neptune, 2 circling around Saturn, and 3 traveling around Jupiter. Scientists study extreme environments on our own planet to understand and guide their search for extraterrestrial life. For example, take such places as deep-sea volcanic vents and frozen lakes in Antarctica. They can tell us more about what conditions could support life on other planets. And these missions are led by a team of experts from different institutions that joined into something called Network for Ocean Worlds. They hope to finally find some life outside of Earth. Come on there, we need some new friends. So, hello there, Europa. Picture a frozen moon covered in double ridges that crisscross its surface like scars. Recently, scientists have discovered something exciting. There may be shallow pools of water on Europa, right under its icy surface. These ridges are very similar to those found on the Greenland ice sheet, and if they formed in a similar way to those in Greenland, these pockets of subsurface water may be common on Europa, hiding just beneath its frozen surface. Such pools form when subsurface water freezes and fractures the surface again and again, pushing up twin ridges. It's like when you put a can of soda in the freezer, and it explodes, pushing up the ridges on the surface. These ridges on Europa are up to 984 feet high and separated by valleys half a mile wide. And you know the rule: where there's water, there may be life. Chemicals that are necessary for life may be circulating from the icy shell down to the salty ocean far below the surface. And Europa has already been one of the most popular moons in our solar system when it comes to looking for extraterrestrial life, considering there's a deep ocean beneath its icy shell. Scientists believe this ocean could be 40 to 100 miles deep, which means it could hold twice as much water as all of our oceans combined. Another candidate is this tiny moon called Enceladus, which is about as wide as Arizona. Despite its small size, scientists think it could host some life, just like Europa. The reason? Again, a liquid water ocean and a thin layer of ice that covers it. In 2008, NASA's space probe, Cassini-Huygens, detected plumes of salty water vapor going out from the moon's south pole. Scientists analyzed the plumes and found organic molecules like carbon, nitrogen, and oxygen, which are important building blocks of life. Instead of a thick ice cap, like Europa has, Enceladus might have a thinner coating of ice mixed with crust. The plumes are really fast, which tells us they could be produced by a liquid ocean present at the moon's south pole. Scientists believe that on Enceladus, there's a constant process where water vapor rises up from the surface, then falls back down and turns into liquid water again. And it's been happening for hundreds of thousands of years. This movement could help distribute organic molecules that scientists think are necessary for life to exist. So, there's a chance for tiny living things crawling somewhere on Enceladus. Earth is a pretty awesome place, and there are a lot of factors that make it friendly to life as we know it. But when it comes to finding life beyond our planet, we can't just assume every other place in our solar system needs to have all these factors to have any signs of life. And one of the most promising places is definitely Ganymede, the largest moon in our solar system. It's gray and covered with craters, and it may look boring at first glance, but don't let its dull appearance fool you. We've recently discovered there's water vapor in its atmosphere, and there's more to it than just water. On Earth, we have a lot of other fun and useful factors that make it a good place for life. We have a magnetic field that protects us from harmful radiation, and a big moon that creates tides that help mix up our oceans. We also have a deep liquid water ocean and land masses with different elevations that create a variety of environments for life to thrive. Ganymede has some of these factors as well. A magnetic field check. Plus, it's Jupiter's biggest moon, so tidal forces are present there too. Ganymede is tidally locked to Jupiter, which means it always shows the same face to the gas giant. But even though it's so close to Jupiter, Ganymede still manages to rotate around its own axis every 7 days. A magnetic field and strong tidal forces are factors that could help create and maintain a liquid water ocean deep beneath the moon's icy surface. And this ocean may not be just for potential galactic vacations. It may also harbor life. Let's head to Io, the third largest Jupiter's moon. We're talking about a very special place since it's the most volcanically active body in our solar system. Yep, there are more than 400 active volcanoes that shoot out gas and other stuff there. This helped with creating a thin gas atmosphere, mostly made of sulfur dioxide with traces of oxygen. Volcanoes also make certain parts of Io really hot as 3,000 degrees Fahrenheit. Some other areas are very, very cold, minus 202 degrees Fahrenheit. Life could hardly develop in such extreme conditions. Plus, Io doesn't have water or organic chemicals, and it orbits within a ring of dangerous radiation. But scientists believe there might have been life on Io a long time ago, maybe even in some other form that we don't know about today. It could still be there, deep under the moon's surface. Some simulations suggest that Io formed in an area with lots of liquid water, which combined with its heat could have fostered life. But any life on the surface would have been destroyed by the radiation after only 10 million years of existence. So, if there's life on Io, it's probably deep underground, safe from all the crazy radiation at the surface, like people building entire cities in all those apocalyptic movies, hiding from whatever's out there on the surface. So to check that out, we'd need to send a special probe to find it. But building a probe that could land on Io and drill deep enough to find life is a very big challenge. And we're not quite there yet. Mars is a planet that scientists have studied a lot. They believe the red planet used to have liquid water and freshwater lakes on its surface. It's way better than what we have at the moment, just some plain ice caps on Mars' poles. But there could be some organic compounds present in its crust. These days Mars is extremely cold and has a thin atmosphere. Not very promising. But some scientists think the red planet used to be much warmer and more hospitable. Hopefully all those rovers and probes will bring us some awesome news and evidence of life.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them. Pluto, an exoplanet and now the most famous dwarf planet in our solar system, is hiding somewhere far, far away in its dark corner. The temperature of Pluto's surface is freezing. I mean, wow! At first sight, it's just a distant, icy, and barren celestial body. But could Pluto be hiding something? Maybe even life? Scientists found out that, despite it being so far from the Sun, its interior is still warm. It's been that way ever since Pluto formed. Under the haze-layered atmosphere of Pluto, there's a frigid surface full of craters and impure water ice. There's also a large impact basin flooded by frozen nitrogen. And below that icy crust could be an internal ocean. When the surface of a planet stretches, it mostly leaves many fractures behind. The same goes with Pluto. You can see there are numerous cracks across its water ice crust. They're of all ages. Some even possibly date from 4.5 billion years ago, from the times when Pluto was still forming. The dwarf planet probably grew because it slowly accumulated small pieces of icy material. It condensed during the time when the outer region of our solar system was forming. This process was going intensely and fast enough to melt the base of the icy layer. The surface of Pluto extended as liquid water at the top of the ocean froze onto the base of its ice crust during its first 500 million years. The ocean may have stopped freezing for the next billion years. The buildup of radioactive heat temporarily balanced the rate of heat escape to space. But as Pluto produced less radioactive heat over time, the roof of its interior ocean continued to freeze, and it probably turned into a 120 miles thick layer between the rock and ice. Crusts were the first hint there might be an ocean there. Scientists got the second potential piece of evidence when they realized the icy shell had managed to glide across an essentially frictionless interior and reorient itself. And it's not just about the ocean here. The cool thing is that wherever there's water, there could be life. A potential ocean under an icy crust is not something that possibly exists only on Pluto. Some icy moons of our solar system have it too, like Saturn's moons Enceladus and Titan, and Jupiter's Europa. Enceladus and Europa could both have salty liquid oceans. Plus, they have similar water plumes erupting from their interior. These geysers tell us these moons have their own source of energy, probably because of radiation or gravity. Either way, that energy is what could support life. Have you heard of Ceres? It's our closest dwarf planet, the biggest object in the asteroid belt between Jupiter and Mars, and the first asteroid we discovered at the beginning of the 19th century. People even called it a planet then. Although it's not so popular, there's a possibility Ceres has a subsurface ocean too. Geysers could be the first sign of that. The water vapor plume could be a result of a meteorite strike that exposed subsurface ice to outer space. Ceres may have its own atmosphere too. This dwarf planet is relatively far from the Sun, but its surface temperature could go up to minus 37 degrees Fahrenheit. At these temperatures, if there was water ice at its surface, it would quickly change to gas, and this could create an atmosphere around this intriguing dwarf planet. Not just oceans, there are many volcanoes across our solar system too. Mercury, Venus, Mars, and Io, one of Jupiter's moons, have them. But apart from the Earth, Io is the only one that has more than 400 active volcanoes. 150 of them erupt at any given time. Scientists suspect there could be some volcanic activity on Venus and Jupiter's moon Europa too. But they can't check if that's true because Venus has an extremely thick atmosphere and Europa has a thick ice shell. And even though volcanoes in other spots are no longer active, we know they used to be because of specific landforms they left behind: hills, valleys, plains, mountains, and especially lava channels. It's like when you're watering your plants on the front porch, you see water flowing down your sloped driveway along specific pathways. This creates small channels, a lot like lava does. Our moon may have also had active volcanoes back in the age when dinosaurs were still roaming around. If they had had telescopes, they might have seen something spectacular: lava fiercely oozing from the surface of the moon. Astronauts took images of Ina, an unusual volcanic deposit on the moon, and there are 70 similar patches in the volcanic plains they found on the side of the moon that faces our planet. Some of them are over 1 billion years old, but some could have been formed less than 100 million years ago, and dinosaurs went extinct 66 million years ago. Speaking of dinosaur extinction, could Jupiter have been the main culprit for that? No one knows where this space rock that hit our home planet 66 million years ago came from, especially with such force. It left a crater off the coast of the Yucatan Peninsula in Mexico, and it probably caused earthquakes, tsunamis, and fierce volcanic eruptions that brought troubles not only to dinosaurs, but to nearly 3/4 of all animal and plant life on Earth. But some believe Jupiter was the one that flung the comet into the Earth. Gravity is a tricky force that can make the solar system act like a big pinball machine. Jupiter is our most massive planet, which means it has extremely strong gravity. It's like a guardian of our solar system that kicks many incoming comets away, sometimes bringing them pretty close to the Sun. As they get there, these comets can experience extremely strong tidal forces that break them apart and, in the end, create long chunks of a comet. And one of these chunks probably went towards the Earth. Have you heard of the story of Triton? Neptune has 13 moons, and Triton is the largest of them. It's the only giant moon in our solar system that has a retrograde orbit. It means it circles its parent planet in the opposite direction of its rotation. Scientists believe that's because Triton used to be in the Kuiper Belt, a disc-shaped area located in the outer solar system, past Neptune's orbit. And it's possible that Neptune's gravitational force pulled it out of that region millions of years ago. Pluto may have originated within the Kuiper Belt too. Pluto and Triton are almost the same. They have similar density, mass, and surface material. Now Triton is locked away in synchronous rotation with its parent planet Neptune, far away from what we believe is its homeland. Now, the most distant object we've discovered so far in our solar system is a mysterious planetoid called, wait for it, Far, Far Out. 1 astronomical unit is the average distance between the Earth and the Sun, around 92 million miles. Well, Far, Far Out is 132 astronomical units from the Sun, 4 times farther away than Pluto. Since it's so far away, Far, Far Out needs about 1,000 years to finish a single circle around the Sun. Far out! Have you ever imagined what would happen if 2 gas giants collided? The chances are small, but if something like this happened, not much matter would be lost, although it depends on the angle and the speed of impact. A head-on collision would make them completely merge and not lose any matter at all, whether we're talking about their gaseous envelopes or their solid cores. But at high speed, their 2 cores would merge and both planets would lose most of their envelope gas. At very, very high speeds, bam, both are gone. If there was an oblique collision, 2 cores could completely avoid each other. Planets would merge, but a substantial fraction of their gases would vanish into space. And in a very oblique collision, kind of like a sideswipe, planets would keep going like nothing happened. There's no evidence for that, but one theory even says Jupiter and Saturn, or at least one of them, might have formed by merging from smaller gas planets. Yep, it's all about gas.
The soil beneath your feet is red and dry. The place is freezing cold. Rusty-colored dust is floating in the air. You make one step, then another. It's hard to move because of the thick layer of dust your feet are sinking into. You're on Mars, and you've come here after hearing some absolutely incredible news. These days, the so-called red planet indeed looks dry and dusty. But scientists think that this world might have been very different a long, long time ago. They have found some evidence of a huge ocean that could have existed on the surface of Mars about 3.5 billion years ago. And this ocean probably covered hundreds of thousands of square miles. It all started with numerous satellite images of the surface of the red planet. They were snapped at different angles. As a result, researchers managed to construct a relief map of the area. They charted out more than 4,000 miles of specific formations that had most likely been carved by rivers. Those formations could also be channels, once carved out on the sea floor. Scientists used the data gathered by the Mars Reconnaissance Orbiter in 2007. They analyzed the thickness of the ridges and their angles and locations. Their main goal was to explore the topographical depression called Aeolus Dorsa. It turned out that all those years ago, this part of the red planet had been undergoing a series of constant changes. They could have been caused by the rapid movement of rocks, pulled around by currents and rivers. as well as noticeable increases in sea level. Researchers also noticed a pretty clear boundary that separated the southern highlands of Mars, elevated and highly cratered, from the smooth lowlands of the planet. It looked very similar to a shoreline left by a ginormous ocean. This all likely means that in ancient times, there indeed was an ocean on the surface of Mars, and a large one at that. What's even more exciting is that the existence of such an ocean might mean the existence of life. This discovery can tell scientists a lot about the ancient climate on the red planet, as well as its evolution. We now know there had to be a period on Mars when the planet was quite warm, and its atmosphere was thick enough to keep so much liquid water. What's even more incredible, the climate in the northern hemisphere of Mars 3 billion years ago could have resembled the one we have on Earth nowadays. But then, where is this ocean now? What happened to it? Perhaps the climate of the red planet was becoming cooler, and the surface of the ocean froze. There's a theory claiming that these days, the ocean remains in its frozen state, deep under a layer of rock, debris, and dust under a northern plain called Vastus Borealis. Or the ocean's waters could have been lost to the atmosphere, and eventually space through the process of atmospheric sputtering. During this process, atoms get knocked away from the atmosphere after colliding with high-energy particles coming from the sun. Anyway, the theory of an ocean that once covered a substantial part of Mars's northern hemisphere hasn't been confirmed yet. Scientists are still arguing about its existence. As for now, Mars is a very cold world with an average temperature of -80 degrees Fahrenheit. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. The ocean that might have existed on Mars isn't the only awesome thing about this planet. Let's speak about those sandstorms raging on the red planet. In movies, they're depicted as incredibly powerful forces of nature, destroying astronauts' camps and tearing their spaceships into pieces. But how much of it is true? Mars is indeed infamous for producing dust storms so massive they can be seen by telescopes on Earth. They sometimes cover continent-sized areas and can last for weeks at a time. But besides them, there are much rarer storms that occur once in 3 Mars years, which is about 5.5 Earth years. Such storms are larger and much more intense than regular ones. They encircle the entire planet. That's why scientists call them global dust storms. At the same time, it's unlikely that even a global dust storm could cause serious harm to astronauts or their equipment. Even though Martian storms are massive, the wind speed reaches 60 miles per hour tops. That's less than half the speed of most hurricane-force winds on Earth. Plus, this comparison of wind speeds can be kind of misleading. The atmosphere on Mars is just 1% or so as dense as the atmosphere on our planet. It means that the wind there needs to blow much faster to cause any damage, or even fly a kite. Now let's move to the next amazing phenomenon spotted on the red planet. When you look at it from a distance, it looks like an eye. There are even some winding channels that look like veins running through the eyeball. But the closer you get, the less the formation looks like an actual eye. It's actually a giant crater, almost 19 miles in diameter. Around the crater, which looks as if it has a pupil, there are other, even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once, water filled the ginormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Your next destination is Valles Marineris. That's an enormous canyon, or rather, a canyon system, that runs along Mars's equator. It stretches for more than 2,500 miles. It's also 4 times as deep as the famous Grand Canyon on Earth. The thing is so huge, It could span the entire continental United States, from the Pacific to the Atlantic Ocean. Most scientists think that Valles Marineris is a huge tectonic crack in the crust of the red planet. It could have formed when the planet was cooling down in the distant past. Another breathtaking sight on Mars is the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which means it's almost the same size as the state of Arizona. The mountain is also 16 miles high and rimmed by incredibly tall cliffs. To imagine the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, around 2.6 miles high and 75 miles across, which actually sounds pretty impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands, from Kauai to Hawaii. Scientists have been wondering for quite some time why this volcano is so large. It might be the result of lower surface gravity and higher eruption rates. Or the reason may be the red planet's crust, which is very different from Earth's. On our planet, the crust is made up of 15 to 20 moving tectonic plates. As plates move over hotspots that produce lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. Now, if you visited Mars and decided to go on an evening stroll, you'd witness a strange phenomenon. It occurs on the red planet after sunset, when temperatures fall below -80 degrees Fahrenheit. A bizarre, mysterious glow spreads across the Martian sky. Unfortunately, without special equipment, you wouldn't be able to observe this soft glow. Visible only in ultraviolet light, this night glow is the result of chemical reactions that occur dozens of miles above the surface of the red planet.
Across millennia, scattered among clay tablets, sacred scrolls, and whispered myths, humanity has preserved haunting tales of a celestial anomaly, a rogue planet, a cosmic saboteur whose rare appearance heralds disaster and upheaval. The Sumerians called it Nibiru, the planet of crossing. Egyptians feared it as the destroyer. Biblical texts knew it as the wormwood star. Are these merely the colorful myths of ancient peoples, or are they fragmented memories of an all-too-real cosmic threat? Modern science, once quick to dismiss such legends, is now forced to reconsider. In 2016, astronomers Konstantin Batygin and Mike Brown from Caltech presented mathematical evidence suggesting the existence of a massive planet at the far edge of our solar system, Planet 9. Their calculations describe a world 5 to 10 times the mass of Earth, on a highly elongated orbit that takes between 10,000 and 20,000 years to complete a single revolution around the Sun. Here's where ancient myth and modern astrophysics begin to blur. Sumerian cuneiform tablets, dating as far back as the 4th millennium BCE, contain astonishingly accurate astronomical data. They describe a solar system of 12 celestial bodies, including a mysterious 12th planet, Nibiru. How did ancient people know about Neptune, discovered only in 1846, or Pluto in 1930? Were they simply guessing, or did they remember something we've forgotten? One of the most controversial voices in this debate is researcher Zecharia Sitchin. He spent decades interpreting ancient Mesopotamian texts and proposed a radical theory that Nibiru is a habitable world with a sweeping elliptical orbit, home to an advanced race known as the Anunnaki, beings who once visited Earth. Mainstream academia has rejected Sitchin's translations, but the uncanny parallels between his claims and recent astronomical findings are hard to ignore. Let's focus on what the data tells us. something is warping the orbits of distant objects in the Kuiper Belt, a vast icy region beyond Neptune. These objects behave as if being shepherded by a massive, unseen force. The dwarf planet Sedna, for example, follows a wildly unusual orbit that can't be explained by known gravitational influences. And then there's the Kuiper Cliff, an abrupt drop-off in the number of objects beyond 50 astronomical units. What's causing it? Something or someone. These anomalies have left astronomers scratching their heads and have fueled growing speculation that a massive, unseen planet is hiding in the dark outskirts of our solar system. Ancient texts from multiple civilizations describe apocalyptic upheavals linked to a celestial intruder. The Egyptian Ipuwer papyrus eerily recounts plagues and chaos. The river is blood, the earth turned upside down, days are shrouded in darkness. The Babylonian Epic of Era speaks of a time when the stars left their appointed paths. These aren't just poetic metaphors. They're historical shockwaves echoing from a forgotten trauma. So what happens if Nibiru, or Planet 9, makes its next approach? Even without a direct collision, the consequences could be catastrophic. Its gravity might tilt Earth's axis, triggering sudden climate shifts. It could awaken tectonic fault lines and stir dormant volcanoes. Disturbed asteroid belts might send deadly space rocks hurtling toward us. It could disrupt our magnetosphere, disabling electronics and satellites. But perhaps the most chilling aspect of this theory is the cycle. Sumerian texts suggest that Nibiru returns roughly every 3,600 years. If this is true, its last passage might have occurred around 1600 BCE, a time curiously aligned with the collapse of Bronze Age civilizations, a period marked by mass migrations, natural disasters, and inexplicable cultural decline. Was this coincidence or consequence? The clock might be ticking again. Today, the hunt for Planet 9 continues, using the world's most powerful telescopes and cutting-edge simulations. We stand on the edge of either confirming the greatest myth ever told, or revealing that ancient peoples tried, in the only language they had, to warn us. It may not bear the name Nibiru. It may not carry golden tablets or alien emissaries. But if it exists, its return will reshape everything we think we know about history, science, and our place in the cosmos. One thing is certain, our solar system is far from tamed. It harbors secrets in its coldest, darkest corners, riddles older than civilization itself. And perhaps, just perhaps, the old stories were never stories at all. Maybe they were prophecies. Maybe they were the echo of survivors. Maybe the star of change is already on its way.
Ah, Earth. The third rock from the Sun. The blue planet. You get it. Its atmosphere is made up of around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide. A nice balance for any living creatures to breathe. The weather here is also perfect for life to exist, unlike places like Saturn, Mercury, or any other celestial object in our solar system. We have the troposphere to thank for that. It's the densest part of the atmosphere on our planet and is 5 to 9 miles wide. It's the layer of the atmosphere that always affects our weather and secures the right conditions for life to exist and to have bodies of water. Earth is just sitting in its orbital path, minding its own business, revolving around the Sun until, BAM! Venus and Mars swoop in and spoil the fun. No one wants to leave poor Earth alone. These two relatively large celestial objects moving toward Earth will have dire consequences for our planet, starting with changes in its orbiting trajectory path. The planets' orbits in the solar system have to maintain the right balance so that nothing goes haywire. Of course, if any large object approaches Earth, it would throw our orbiting path off course. The planets will revolve around each other, which will cause plenty of natural disasters on our lands. This will also affect our rotation timing, potentially slowing it down. Days will not flow but drag by. Animals that rely on daytime will need to readjust their biological clocks. Nocturnal animals will also need to figure out how to cope with the long nights. Humans have adjusted pretty well to the 24 hours a day timing. Time itself is just a human construct to measure things. We'll have a tough time sleeping and adjusting to the stretched day. Marine animals rely on the natural current flow to migrate around the oceans. With Mars and Venus crashing the party, it looks like they will also need to find new paths. Birds migrating to other lands throughout the year will also be confused and not know what to do. In general, the Earth's temperature will rise, and massive heat waves and permanent climate changes will occur. This brings us to our next issue, the heat. The radical temperature rise will turn everything into a barren desert. It'll be summer all year long, especially if Venus is in the picture. Most of the planet will dry up and won't be suitable for growing crops. Venus is hot, really hot. Even though it's not the closest planet to the Sun, it's still the hottest. The temperatures on Venus are close to 900 degrees Fahrenheit, which will melt you like an ice cube. The lands on Venus are generally flat, probably due to the temperatures. It's mainly hot because its atmosphere is thick and traps the hazardous gases inside. If Venus inches its way towards us, it'll invite those gases to our atmosphere and compromise it. Mars, or the red planet as we know it, is very cold. That might stay the same if it starts rotating around us. It's also home to the largest dormant volcano in our solar system, which makes Mount Everest look like a tiny bush compared to a tree. With so much instability, it might just wake up one day and spew out molten lava. Mars has a very thin atmosphere, which makes the planet chilly. Its gravity is quite similar to ours. It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and sunset. The three planets orbiting each other will eventually collide. It's just a matter of time. And the Moon, just hanging out like a fly on the wall, will be so insignificant that something will eventually throw it off course and another planet will capture it to its orbit. Or, in the most dire case, it will collide with one of the two intruding planets. Earth will experience extreme tidal waves like nothing before. The two new planets revolving around Earth will cause a major imbalance, making our gravity shift out of control. Each tidal wave will be bigger than the previous one and will cover the dry land. Plenty of little scattered islands in the oceans will be completely submerged. Coastal cities and towns will also be home to fish. Flat countries in general will need boats to get around. Dams and dikes won't be enough to stop the water from coming in. Everyone needs to move towards higher ground to escape the floods. With the climate getting hotter, the polar caps will melt like ice cream on a sweltering summer day and add to the water level rising. Within a few months, the whole Arctic will be nothing but liquid. But wait, there's more! The crust will wear out due to the instability of the Earth's surface and fluctuating gravity. The Earth's crust is mainly made up of oxygen, which means we're basically walking on air. We might experience more earthquakes than before, and dormant volcanoes will wake up from their deep slumber. The skies will be covered in ash, making flights impossible. No one can travel by sea or by air. Importing and exporting will become history. The overall climate will get hotter, just like in Venus. The three planets orbiting each other and their huge mass might even unintentionally welcome other planets and celestial bodies to join the party. So, what if Jupiter decided to turn up? Now, Jupiter is the largest planet in our solar system. To give you an idea, the Earth would be just the size of a grape if Jupiter were the size of a basketball. It also has the largest storm we can perceive. That's known as the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. Now, by the time you're done watching this video, you can expect the storm to still be going at it. Since the planet is huge, gravity must be quite strong here. It also has many moons, some of them of our little Earth. There will be no room for any proper space among the planets. Jupiter's moons will be thrown off course and latch onto other planets around. Some of the moons might collide with each other, causing massive debris to be displaced all over the place. The gravity of the planetary party will attract comets to enter the atmosphere, potentially crashing down on us. Oxygen levels will deplete, so the Earth's crust crumbling will continue. It'll rip open the ozone layer, causing heavy strokes of ultraviolet waves to enter our atmosphere. We won't be able to step outside for too long without some protective gear and oxygen tanks. Human civilization will change drastically. We'll all live in sheltered containers that will provide clean air and safe and filtered sun rays. The shelters will be sturdy enough to withstand frequent earthquakes. We will grow only enough crops to sustain ourselves until we leave the Earth. Since it'll only be a matter of time before the planets collide, the next step would be to create large rocket ships to fly us out of the Earth. With Mars, Venus, and Jupiter revolving close to us, it won't be easy to do so. All the space debris will be blocking us from exiting the space zone area. The only safe place outside this region will be many millions of miles away, where only single planets exist. They may or may not have the conditions to host life, but humans will have the technology to land just about anywhere with similar gravity and construct the right shelters. Eventually, Mars, Venus, Earth, and Jupiter will collide with each other and break like eggs, like a big space omelet. Don't forget the moon's crashing and breaking in the mix, but we'll already be far, far away by then, hopefully.
For centuries, humanity has believed in a linear path of evolution, a slow, steady climb from primitive survival to modern innovation. But what if that story is incomplete? What if the turning points in our development weren't purely natural? Roughly 6 million years ago, an ancestor of modern apes rose to its feet, setting in motion a journey that would eventually lead to Homo sapiens. For hundreds of thousands of years, progress was glacial. We tamed fire, carved basic tools, and lived hand-to-mouth existences. Then, just 20,000 years ago, everything changed. In a span shorter than a blink in evolutionary terms, we went from hunter-gatherers to architects of vast megalithic temples, builders of empires, and eventually, explorers of space. How do we make sense of that? Some argue we can't, not with conventional science alone. This explosion of intelligence and innovation has led to alternative theories. One of the most provocative, that we had help from beings far more advanced than ourselves. Welcome to the world of the Anunnaki. They're more than myth. They're the center of a sprawling theory that suggests humanity's greatest leaps weren't entirely human. According to ancient Sumerian texts, these so-called gods came not from the heavens in a spiritual sense, but from the sky in the most literal way imaginable, another planet. And they didn't just visit, they stayed, they ruled, and perhaps most importantly, they altered us. Long before Egypt erected its pyramids, or Stonehenge crowned the English countryside, the Sumerians were building cities, inventing writing, crafting legal codes, and mapping the stars with uncanny accuracy. Their civilization bloomed in Mesopotamia nearly 7,000 years ago, and it left behind cuneiform tablets that continue to baffle and inspire. These records tell of beings called the Anunnaki, translated as those who came from heaven to earth. They introduced tools, language, agriculture, and even mathematics. But the texts also hint at a darker truth. These beings didn't just uplift humanity. They enslaved it. Why? One word: gold. Ancient records describe massive gold mining operations that predated technological society. But here's the twist. To early humans, gold was worthless. It had no utility, no exchange value, no role in survival. Yet we dug for it with obsessive intensity. According to the Sumerians, the Anunnaki needed gold, not for jewelry, but for survival. Their home planet, Nibiru, was dying. Its atmosphere was decaying, and gold particles, when dispersed in the air, could reflect solar radiation and purify environmental conditions. Earth had gold, lots of it. And so, the Anunnaki came. At first, they did the labor themselves, but mining Earth's crust was exhausting. Frustrated and desperate, they considered a more efficient solution: genetic engineering. If they could merge their DNA with that of early humans, they could create a workforce suited to the task, strong, obedient, and intelligent. Enki, one of the Anunnaki leaders, took the lead. Early experiments were monstrous, deformed hybrids that echo legends of giants, cyclops, and mythic beastlists. Many were destroyed, others abandoned. But eventually, success came. Using one of their own as a surrogate, they implanted a fertilized egg, part Anunnaki, part hominin. The result was a child named Adamu. Sound familiar? To many, Adamu is the precursor to the biblical Adam. The parallels between religious creation stories and Sumerian myth are too sharp to ignore. Created in our image, from clay, the Sumerians were telling a story that would echo through ages, morphing into sacred texts and oral traditions around the globe. Adamu and his descendants became laborers, building a society under Anunnaki rule. But something strange happened. These hybrids didn't just follow. They learned, they questioned, they grew in number and complexity. Eventually, they became us. Here's where the timeline warps. Homo sapiens have existed for over 300,000 years. Yet for most of that time, we were indistinguishable from animals in both behavior and cognition. Then, seemingly overnight, we developed art, architecture, religion, governance, and science. No smooth curve, just a spike. How? Some point to climate shifts or population booms, but others look to Nibiru. Modern astronomers have observed gravitational anomalies beyond Neptune, suggesting the presence of a massive unseen planet. Dubbed Planet 9 or Planet X, it eerily mirrors the Sumerian Nibiru, which they claimed had an elliptical orbit that brought it near Earth every 3,600 years. The timing of historical jumps in human development? It aligned suspiciously well. According to legend, as Nibiru approached Earth, the Anunnaki would return. Some think they never left. Others believe they're watching, waiting. What did they look like? Relics suggest beings 3-4 meters tall, with elongated skulls and high foreheads, features mimicked by ancient civilizations who bound the skulls of their elite. They wore ornate robes, had light skin, and luminous eyes. Their leader was Anu. His sons, Enki and Enlil, managed Earth's operations. The Anunnaki might have left behind more than just myths, hidden knowledge, lost technology, even genetic markers that still echo within our DNA. The idea is unsettling, yet alluring, that our creators may return, that we are not the pinnacle, but the product. And here's another twist. Some researchers argue that humans don't even belong here. In the book, Humans Are Not From Earth, anomalies in our biology are explored. Why are we uniquely vulnerable to sunlight? Why do we suffer chronic back pain? Why are childbirths so difficult? Every other species fits perfectly into Earth's environment. We arguably do not. Could it be because we're hybrids? Part Earth, part something else. From gold mines to rocket ships, from caves to satellites, our species has always been driven by something deep and inexplicable. Maybe it's curiosity, maybe ambition, or maybe, just maybe, it's a buried memory of where we came from and who made us. So next time you look up at the night sky, remember, the answers to humanity's origin may not lie beneath our feet, but far above our heads. And the Anunnaki, their story isn't over. It may be just beginning. The Black Knight, the mystery that won't let go. What if I told you that there is an object in space that defies explanation, an object that was not created by any space agency, has no official owner, and whose origin remains shrouded in mystery? You might think it's just another fantastic myth or a publicity stunt, but the story of the Black Knight will surprise you. You've probably heard about the Black Knight, a satellite that wasn't launched by humans but has been orbiting our planet for years. But how did it end up in orbit, and who is behind its creation? The answer to this question is hidden in the dark corners of space, and this enigma continues to haunt scientists. Signals from space, the beginning of the journey. Long before humans even thought about creating satellites, our world was already receiving signals from space. It all started in 1899, when the brilliant Nikola Tesla was conducting experiments on wireless energy transmission. In fact, he didn't just come up with ideas for future technologies, but also began to pick up strange signals that couldn't be explained by any earthly sources. This wasn't just static, this was a clear signal, which Tesla interpreted as a message from outer space. It was too strange to be a coincidence. But what was it? For a long time, scientists and researchers couldn't find an explanation. Ordinary radio waves, it seemed, couldn't have caused these signals. This mystical phenomenon marked an important milestone in the history of space exploration, but it still didn't provide any clear answers. Forgotten satellites and space paranoia. Decades passed, and by 1954, more strange reports began to emerge. During this time, amateur radio operators around the world began picking up unusual signals, seemingly coming from objects in Earth's orbit. Amid the Cold War, this sparked concern. If the Soviet Union could launch satellites, it meant the US should have been doing the same. But here's what was strange. No one knew about satellites moving along unconventional orbits. At this time, rumors started circulating about mysterious objects keeping watch over our planet. Some claimed these were satellites created by an unknown civilization. Others suggested they were just space junk, but none of the theories could explain the behavior of these objects. The Black Knight, the first glimpse. In 1960, the rumors intensified, and many experts began stating that Earth was being monitored by a mysterious satellite. Then, in 1998, during the STS-88 mission, astronauts accidentally snapped a photo while flying, capturing something that would be debated for years. In one of the images, a dark object was clearly visible against the backdrop of Earth. It looked like an artificial satellite, but its shape and structure didn't resemble anything we knew. This was too strange to be ordinary debris. Moreover, the object was clearly moving in orbit, not just some discarded space junk. For everyone who saw these photos, this dark object became the embodiment of a true cosmic mystery, full of unanswered questions. What was it really? There are many theories, but none of them offer a definitive answer. Some scientists argue that the Black Knight is an ancient satellite placed by an unknown civilization, perhaps even before humans arrived. This satellite could have been designed to monitor our planet, or serve some other purpose that remains unfathomable to us. It seems like it's from another era, another time. Others believe the Black Knight is an artificial object created by extraterrestrials. The theory that aliens might be observing us is nothing new. According to some researchers, this object could have been sent as part of a study of earthly life, acting as some sort of spy satellite to watch humanity. It might be part of a hidden project that's beyond our understanding. But there's also the more down-to-earth explanation. Some believe it's just space debris that accidentally ended up in Earth's orbit. But with each new photo and each new investigation of the Black Knight, this theory seems less and less likely. Why do we still not know? What's most surprising about this story is that, despite all efforts by scientists, we still don't know what the Black Knight actually is. Official agencies remain silent, and space agencies aren't rushing to share any information about it. Perhaps this is the greatest mystery of all. The Black Knight isn't just a satellite, but something more, something beyond our understanding. It might be a witness to ancient history, or a messenger from the future, observing our development. This object continues to inspire researchers, raise questions, and stir the imaginations of people worldwide. No matter what's really behind it, the Black Night remains a living symbol of the mysterious and unexplored cosmos. We can only guess what it really is and what answers it holds. But one thing is certain, its mystery will not leave you indifferent. The future of the Black Night. With each passing year, the mystery of the Black Night grows deeper. Space missions continue to explore our satellite world, and scientists are increasingly discussing its origin. Who knows, perhaps one day we will solve this riddle. But until then, the Black Night will remain one of the most intriguing objects in space. And maybe, just maybe, we will witness the moment when a new chapter of history unfolds in space. Perhaps this dark satellite will be the key that opens the door to a new world, a world we still don't understand. In December 2016, a bombshell revelation rocked the world of classified intelligence. WikiLeaks had released top-secret Pentagon documents exposing a hidden war between the US Air Force and unidentified flying objects. According to these explosive files, the center of this interstellar conflict was none other than Antarctica, Earth's most remote and enigmatic continent. During the summer of 2016, the US Missile Defense System detected an entire fleet of UFOs rising from the Southern Ocean and heading at high speed toward the Mexican coast. American fighter jets were immediately scrambled, but just as suddenly as they appeared, the mysterious objects vanished from radar, leaving behind only questions and ripples of fear in high-ranking circles. And this, insiders claimed, was only one of many such encounters in a long-running, covert battle beneath the ice. The story spread like wildfire across forums, alternative news sites, and YouTube channels. Eyewitnesses reported that the surfacing UFOs created enormous waves, damaging ships in the area. Other reports spoke of alien bases discovered deep beneath Antarctic ice, with entire zones marked off-limits to the public. Some even claimed that Russian President Vladimir Putin was being briefed on secret skirmishes between US forces and non-human entities. The truth seemed ready to explode into public view. But how much of this is real? And did WikiLeaks actually publish such world-shattering documents? Since 2010, WikiLeaks has indeed released hundreds of thousands of files, diplomatic cables, military reports, and surveillance data. While some documents reference unusual aerial phenomena, none mention extraterrestrial conflict in Antarctica. The story's origin can be traced to a post on European Times, a dubious website known for spreading unverified claims. It cited anonymous Russian intelligence officers as the source. From there, the tale snowballed through conspiracy blogs that forged fake scans of supposed US documents, complete with seals, signatures, and official stamps. Yet under closer examination, these documents crumble. Fonts are inconsistent with military formatting. Signatures are copy-pasted from unrelated sources, and crucially, no corroborating evidence exists. Why did this theory stick? Despite its shaky foundation, the story refuses to die. Why? 1. Real secrecy in Antarctica. The continent is governed by strict international treaties. Military activity is restricted, creating a veil of mystery that invites speculation. 2. Historical myths. Tales of Nazi bases, ancient alien ruins, and lost civilizations buried under Antarctic ice have long fueled the imaginations of conspiracy theorists. 3. Real UFO sightings. The US military has confirmed encounters with unidentified aerial phenomena, such as the famous 2004 Tic Tac incident, adding legitimacy to UFO narratives. 4. The WikiLeaks halo. For many, anything associated with WikiLeaks automatically seems credible. That association lent weight to the fabricated documents. Antarctica's vast, silent expanse is a fertile ground for myth-making. From secret bases to wormholes, the continent has become a canvas for every kind of fantastical speculation. Even real locations like Lake Vostok, a subglacial lake Russian scientists spent decades drilling into, have been dragged into alien lore despite zero scientific evidence. Unusual military flights near Antarctica in 2016 and 2017, including Boeing RC-135 reconnaissance planes, added fuel to the fire. Officials cited training and climate research, but to believers, they were part of a hidden campaign against otherworldly threats. The tale of a secret UFO war exposed by WikiLeaks is thrilling, but ultimately, it doesn't hold up. There's no credible documentation, no trustworthy sources, and no confirmation from WikiLeaks itself. Like many conspiracy theories, this one blends fragments of truth with layers of fiction, creating a narrative too seductive to let go. But seductive isn't the same as true. Behind the allure lies a stark reality. No aliens, no Antarctic war, just another myth, thriving in the shadows of secrecy and our eternal hunger for the extraordinary. Still, as long as Antarctica stays silent, the legends will grow, because nothing feeds the imagination like a blank, frozen slate at the edge of the world. The moon has always been a source of wonder, myth, and mystery. It lights up our nights, controls the tides, and marks the rhythms of time. But what if the moon isn't what it seems? What if this familiar, glowing orb in the sky is not a natural object at all, but a hollow, perhaps even artificial construct? That's the central idea behind the hollow moon theory. A concept that blends science fiction with ancient lore and dares to question everything we think we know about Earth's closest celestial neighbor. Let's explore the bizarre clues and strange stories that fuel this unsettling possibility. During the Apollo missions in the late 1960s and early 1970s, NASA astronauts left behind scientific instruments, including seismometers. In 1969, the Apollo 12 crew intentionally crashed a portion of their spacecraft onto the lunar surface. The result shocked mission control. The moon reverberated for over 50 minutes. Scientists said it rang like a bell. This was not a one-time event. Later impacts during Apollo 13 and 14 produced similar results. Long-lasting, deep seismic vibrations that were unlike anything observed on Earth. Some theorists argue that this behavior could be a sign that the moon is hollow or has vast inner cavities. After all, nothing on Earth behaves that way unless it's mostly empty inside. NASA's explanation is more conservative. The moon has a dry, rigid crust with little water content, which allows seismic waves to travel much farther than they would through Earth's moist, fractured interior. Still, the Bell effect remains one of the strangest lunar anomalies on record. In many ancient cultures, there are legends of a time when there was no moon. Aristotle mentioned that the Pelasgians, the ancient people of Arcadia, lived before there was a moon in the heavens. The Zulu people of Africa tell stories of two brothers, Wawane and Mpanku, who brought the moon to Earth, an artificial object, hollow and controlled, which changed the weather and caused great floods. Ancient Sumerian texts also hint at a celestial object that arrived unexpectedly in the sky. These accounts span multiple continents and civilizations, alluding to a world that once turned without a moon. Are these myths simply poetic metaphors? Or could they be distant memories of real events passed down in the only language available to ancient humans, myth and story? The moon is the fifth largest natural satellite in the solar system, and by far the largest relative to the size of its planet. No other moon comes close in size ratio. This alone makes Earth's moon an outlier, but there's more. The moon is precisely the right distance from Earth, about 384,000 kilometers, to perfectly cover the sun during a total solar eclipse. The sun is 400 times larger than the moon, and also about 400 times farther away. This perfect 400 to 400 ratio creates an extraordinary visual phenomenon that allows scientists to study the sun's corona during eclipses. Coincidence? Maybe. But to some researchers, it feels more like design. And then there's the moon's orbit. It's almost perfectly circular, and it's tidally locked, meaning we always see the same face. We never see the far side of the moon from Earth, unless we send spacecraft around it. Why does this object behave so precisely? Is it a natural product of gravitational forces, or something else? In 1970, Soviet scientists Mikhail Vasin and Alexander Sherbakov published a radical paper titled, "Is the Moon the Creation of Alien Intelligence?" They suggested that the Moon may be a colossal, ancient spaceship, an alien construct disguised as a natural satellite. According to their hypothesis, the Moon might have a metallic outer shell with an inner structure that once supported machinery, life, or monitoring equipment. They compared it to a planet-sized arc that could travel between star systems. While their paper was largely dismissed in the West, it planted the seed for countless other theories. Could the Moon be a derelict alien spacecraft? Long abandoned, perhaps watching us still? More recent fringe thinkers have proposed even stranger ideas. Some argue that the Moon might not just be a passive structure, but a kind of anchor for a simulated or controlled reality. In this vision, the Moon is not just hollow, but alive with technology, possibly operating as a monitoring station, memory regulator, or even a civilization reset button. Ancient floods, magnetic pole shifts, and unexplained disasters. Some theorists claim these events correlate with specific lunar alignments or cycles. Others go further, suggesting that the Moon is part of a larger system designed to keep human consciousness limited, trapped in cycles of forgetting and rediscovery. Is the Moon helping to shape our very perception of time, reality, and evolution? It's impossible to prove, and perhaps that's the point. Even beyond the big theories, there are many small puzzles that don't quite fit. For example, when scientists first studied moon rocks, they expected to find thick layers of accumulated dust, possibly several meters deep. Instead, the moon's surface dust was surprisingly shallow. Where did all the debris go? Radio signals sent to the Moon sometimes bounce back with strange delays, suggesting interior reflections that aren't typical for solid rock. And then there are the mysterious transient lunar phenomena. Sudden flashes, glows, or color changes on the Moon's surface. These have been observed by astronomers for centuries, yet remain unexplained. Mainstream science sees the Moon as the product of a massive collision in Earth's early history, a fragment of the young planet that cooled into orbit. But for every answer science provides, there seem to be more questions. Why does this object behave so perfectly? Why do myths around the world speak of its arrival? And why does its presence feel so scripted? Whether you believe in the hollow moon theory or not, one thing is certain: the Moon is far more than just a rock in the sky. It is a mirror to our imagination, a beacon to our ancestors, and maybe, just maybe, a puzzle we were never meant to solve.
It was the year 2015 when US Navy pilots flying training missions off the East Coast saw something truly eerie. They spotted oval-shaped objects moving quickly over the water. They seemed to rotate as they flew. At first, the pilots thought it was just one object, but soon they realized there were many of them, moving in unusual ways. These objects didn't look like normal aircraft. They didn't have visible engines, didn't produce exhaust, and didn't just hover near the sea like helicopters would. Some of them appeared at altitudes of 30,000 feet and were moving faster than the speed of sound. The strangest and scariest thing? The pilots had been observing similar objects almost every day for months. Mind you, those weren't rookie pilots. One of them was an experienced pilot with 10 years in the Navy. He, along with his fellow pilots, knew what typical aircraft looked like and how to stay calm under pressure. It wasn't until 2019 that the public heard about those sightings. That's when the New York Times published an article revealing them. The article included video footage taken by the pilot's plane cameras, which was later confirmed by the US Navy in April 2020. The Navy officially released the videos soon after, In recent years, sightings of UFOs, now called unexplained aerial phenomena, have been reported by other reliable sources as well. The US government has started to take these sightings seriously and has even brought in scientists to quietly investigate what might be behind them. So far, we still don't know exactly what the pilots and others have seen. But this growing scientific interest is pushing us closer to finding out more. While military pilots reporting UFOs might be a recent development, the public has been observing and reporting them for decades. In fact, the UFO craze in the US can be traced back to the summer of 1947. On June 14th of that year, a rancher discovered strange debris on his land near Roswell, New Mexico. At first, he thought it was from a kite. But even after looking through the bits of rubber, tinfoil, paper, and wood, he still couldn't make sense of it. The rancher then told the local sheriff about his find. And since his ranch was close to the Roswell Army airfield, the sheriff reported it to the military. Officers came to check it out, and couldn't identify the wreckage either. The next day, the Army issued a press release saying that they had recovered the remains of a flying saucer. The local newspaper even ran a headline, "RAAF captures flying saucer on ranch in Roswell." But just a few days later, the Army changed its story, claiming the debris was from a weather balloon. By then, though, the excitement over UFOs had already sparked, and UFO fever spread across the nation. Now, UFOs are real, in the sense that people have indeed seen objects they can't identify in the sky. But when people ask, are UFOs real? They usually mean, are we being visited by aliens? And science doesn't have an answer to that yet. After the Roswell incident, UFO sightings became more frequent. People made wild claims, saying they'd met aliens or even been abducted. These stories were mysterious and captivating. No wonder they gained traction. The government didn't help much since it was keeping its own secrets. Eventually, they admitted to hiding something, but it wasn't little green men from other planets. In 1995, the Air Force released a report explaining that the debris found on Brazel's ranch wasn't from a weather balloon, but from Project Mogul, a secret Cold War program that used balloons to detect missile launches of certain countries. As for the alien bodies people claim to have seen, they were crash test dummies used in experiments with ejection seats. In 2021, the US government released a brief report on UAPs, aka unexplained aerial phenomena, stating that they have found no evidence of aliens. At the same time, they acknowledged that many UAP sightings had been recorded since 2004, and those remained unexplained. According to the report, those sightings did not necessarily point to alien spacecraft. Some could be birds, debris like party balloons, secret military projects, or even new technology from other countries. In May 2022, Congress held a public hearing on UFOs, and high-ranking military officials testified there. They revealed that since 2021, 400 unexplained sightings had been documented, but none suggested extraterrestrial life. At the same time, there's more and more evidence hinting that Earth may not be the only place with life in the universe. Earth itself is 4.5 billion years old, and life emerged here around 3.5 to 4 billion years ago. Life on Earth began fairly quickly, which means that the process of life forming wasn't overly difficult. And if life could begin easily on Earth, it's likely that it could also start on many other planets in the universe. The Milky Way galaxy alone contains 1 trillion planets, and there may be trillions more in the universe. Given these numbers, there is a lot of potential for life elsewhere. However, just because there's a possibility of life elsewhere doesn't necessarily mean that aliens have visited Earth. That's why SETI, Search for Extraterrestrial Intelligence researchers, are focused on detecting signs of life elsewhere in the universe, not on studying UFOs. For a long time, most scientists dismissed the study of UFOs as pseudoscience. That's why many researchers interested in UAPs, unidentified aerial phenomena, stayed silent to avoid being seen as eccentric. But this has started to change. In June 2022, NASA created a team of scientific experts to search for the unknown in air and space. The researchers suggested using NASA's huge amount of space data to assist in the study of UAPs. The team also made it clear that studies of UAPs should focus on evidence and data, not speculation. Instead of simply collecting stories or relying on accidental sightings, the researchers use telescopes to capture footage of the sky. They gather this data and then analyze it with the help of artificial intelligence. They plan to add more observatories, and over 100 scientists are already involved. Astrobiologist Julia DeMarines suggests that some UAP sightings could be caused by unusual weather conditions. For instance, spacecraft launched near sunset can create strange effects. The gases expelled by spacecraft reflect only the light reaching the upper atmosphere at that time. And since the sunlight remains reflective for a long period, such sightings can seem unexplainable. UAPs might also be caused by light reflecting off communication satellites. But could UAPs really be alien spaceships? People often expect first contact with alien life to be dramatic, but the reality might be more subtle. Our first encounter with alien life may actually be discovering their technology. For example, we might find a piece of space debris that didn't originate on Earth, like spotting an empty plastic bag blowing through space. We'd know it didn't come from Earth, but we wouldn't know where it came from. Another possibility is that the aliens we might encounter may no longer exist. In 1961, astronomer Frank Drake developed the Drake equation, which estimates how many alien civilizations might be capable of sending signals. The equation considers factors like the rate at which stars form and the number of planets capable of supporting life in a Goldilocks zone, a habitable zone located at the right distance from a star for water to remain a liquid. However, one key factor in the equation is represented by L, which stands for the length of time technological civilizations produce detectable signs of their existence. Humanity has only been technologically advanced for a little over 100 years, in a universe that is nearly 14 billion years old. It means that the timing for civilizations to overlap might be rare. Many civilizations might have existed before us, and many may come after us, but the chance that we overlap with theirs is slim. Despite this, some scientists believe that it won't be long before we find definitive evidence of alien life. Mars has always managed to surprise us, but recently, NASA's Perseverance rover has found something even more bizarre than usual. It happened when it was exploring the Jezero crater, searching for signs of ancient life. At one point, Perseverance stumbled upon a weird rock that later was named Freya Castle. This rock is covered with bright black and white stripes, which makes it stand out against the red, dusty Martian landscape. Okay, we get it, the rock is kinda pretty, but what makes Freya Castle so special? At first glance, it resembles some types of metamorphic rocks you can find on Earth. Such rocks are formed deep within a planet's crust under intense heat and pressure, and it changes their composition and structure. But Mars doesn't have the same kind of tectonic activity we have on our home planet. It means that if Freya Castle is indeed metamorphic, it must have formed under unusual conditions. It could have been a massive impact or volcanic activity billions of years ago. Another theory claims that Freya Castle could be sedimentary. It means the rock was created from layers of material deposited by water or wind. Indeed, Mars once had liquid water flowing across its surface, especially in places like the Jezero crater. It was a lakebed long ago. Now, if Freya Castle is sedimentary, it might have been altered by water, and it would explain its unique banding. Other experts believe that the rock could have undergone changes from hydrothermal activity. Hot, mineral-rich water could have been flowing through cracks, altering the rock's composition. This actually makes sense. The rock was found in a region that had once been submerged in water. Also, since Freya's castle is distinct from the underlying bedrock, it might have come from somewhere else. Perhaps it just rolled down the hill. So, scientists hope that as Perseverance continues to climb the mountain, it will find more rocks of this new type. But the coolest thing about this rock is that it could provide a glimpse into Mars's deeper geological processes. You see, the rock's pattern has been described as resembling boudinage. That's a French term used to describe a structure where layers of rock look like a chain of sausages. Boudinage forms when rocks are stretched and squeezed under high heat and pressure. And it could indicate that Freya Castle appeared deep beneath the Martian surface, before it was pushed up or exposed by an impact. Another possibility is that Freya Castle is a sandstone that has been altered by the planet's winds, combined with past water activity. If the rock was exposed to water, minerals like iron could have seeped in, creating the black and white striped effect. When sandstone is exposed to water or wind erosion, it can develop all sorts of interesting patterns, but no matter what kind of rock Freya Castle is, its presence in the Jezero crater is crucial. Jezero itself is an ancient impact crater that dates back to about 3.8 billion years ago. At one point in the past, the crater was filled with water. It even has a river delta where sediments from flowing water settled. The main mission of Perseverance is to explore this region to look for evidence of past microbial life. Thus, every rock it comes across helps scientists piece together the puzzle of Mars' watery past. So how did Freya Castle end up in the Jezero crater? One theory claims that an impact from a meteorite blasted the rock out from Mars' lower crust and deposited it in the crater. The rock could have also been flung across the Martian surface by the force of the impact. One more idea is that the rock was carried into Jezero by water during one of the periods when the crater was flooded. The slightly rounded edges of the rock confirm that it may have been tumbled and eroded by water, which is typical for rocks transported by flowing liquid. If it turns out that Freya Castle is indeed a metamorphic rock, it could be one of the oldest rock formations ever studied on Mars. And that would be a major breakthrough. It could give us some clues about the planet's early crust, and possibly even its ancient water systems. If the rock is as ancient as it seems, it might bear evidence of Mars's oldest hydrosphere or even some of the earliest signs of liquid water in our solar system. Venus is often called Earth's evil twin. The thing is, this world once started off quite similar to our home planet. But later, something went wrong. These days, the two planets are relatively close and similar in size. But Venus's atmosphere is very different from that on our planet, all thanks to a runaway greenhouse effect that has been going on for a long time. The surface of Venus can get even hotter than the surface of Mercury, 864 degrees F, and the surface pressure feels as if you're more than half a mile underwater. The thick atmosphere presents its own challenges. Its clouds consist of sulfuric acid, which is used in lead-acid batteries, as well as industrial cleaners. And if you decided to land on the planet, you'd have to survive atmospheric entry, with friction heating you up to 20,000 degrees F. Still, people have always wanted to explore this inhospitable world, and we can't but talk about the Venera program. During the 1970s and 1980s, several spacecraft studied Venus from orbit and from its hostile surface for an hour or so at a time. The 10 successful Venera landers provided us with most of the data we have today about the surface of this mysterious planet, including surface composition, direct measurements of atmospheric conditions, and sets of unique images. At the same time, astronomers got their hands on these treasures, only after a series of annoying failures. They started with Venera 1, launched in February 1961. Each consequent spacecraft was somehow improved and upgraded. But it still wasn't until the fifth group of Venus-bound space probes launched in 1967 that one of them, Venera 4, reached its target and sent data from Venus. Before that, Venera 2 and 3, launched in November 1965, were supposed to land on Venus, but both of them failed in transit. 11-foot-tall Venera 4 was a hefty thing. Its bottom lander was a bunch of instruments and a battery wrapped up in a pressure shell equipped with a parachute. This probe reached Venus in October 1967 and successfully launched the lander. The mother spaceship sent the probe flying over the planet, and it entered Venus's atmosphere. Temperatures were reaching 20,000 degrees F, and the entry force was as great as 450 G. It didn't prevent the onboard instruments from analyzing the atmosphere and sending back data. The first recorded temperature was 102 degrees F, and atmospheric pressure was similar to that on Earth. But the deeper the probe went, the higher the numbers became. 10 atmospheres, 20. They kept going up much higher than engineers had anticipated. 93 minutes into the mission, when the probe was still more than 16 miles above the surface of the planet, Venera 4 cracked open near its top and crashed. At the crash point, the measurements showed 22 atmospheres and 530 degrees F. Scientists realized
that they needed a bigger spaceship. After some intense engineering, Venera 5 and Venera 6 saw the light of the day. Engineers did everything they could to make the landing probe stronger, but they were pressed for time. That's why Venera 5 and 6 were not fully prepared when they went on a mission. That's why Venera 5 transmitted data for a mere 53 minutes before succumbing to temperatures of 600 degrees F and pressures of 27 atmospheres. And Venera 6 lasted for 51 minutes. In any case now, the leaders of the project knew what it would take. 840 degrees F, 100 atmospheres, corrosive acids. They seemed to be prepared. They found new materials to build the probe. They got a hotter and stronger test chamber for the trials. They modified the parachute to make the lander fall faster so that the probe could spend as much time on the surface as possible. The lander was also designed in the shape of an egg and made of titanium, so its surface was smooth and had just a few ports, welds, and substructures. The insides were lined with a shock absorber and insulation layer. The chamber was also to pre-chill to freezing temperatures before entry. And Venera 7 was finally a success. It reached the planet in December 1970, separated from the mothership, and went down into the atmosphere. The probe transmitted data for 35 minutes, and things seemed smooth. But then, its chute melted, and the probe dropped like a rock, hitting the ground at 35 miles per hour and bouncing. Then, a second after the landing, the signal was abruptly cut. It looked like the probe crashed to bits. Shockingly, a few months later, while looking through all the data they managed to get, engineers rediscovered the signal. It was super weak and lost amidst the noise. Apparently, when Venera 7 bounced, it misaligned the antenna. The probe rested on its side, which weakened the signal to 1 or 3% of its initial strength. The probe kept transmitting data for 23 minutes. After that, the temperatures got too high and melted its shell. Venera 8, launched in 1972, had a similar design and experienced a similar fate. Venera 9 and 10 were a new generation of probes. They could send back black and white photos. It was actually the probe's main goal, to send the first ever photographic panorama from another planet. Venera 9 and 10 were 5 times heavier than their predecessors and weighed 5 tons at launch. The lander was 6.5 feet tall. It was basically a hermetically sealed titanium sphere that was supposed to hold the instruments. It was bolted with gold wire seals. Inside, there were shelves of beryllium and electric fans, whose main goal was to disperse heat to prevent instrument failure. On the bottom of the lander, there was a shock-absorbing ring. And at the top, there was a titanium ring that looked like a hat. It served as an aero brake. The parachute was supposed to detach at 30 miles above the surface, and the aero brake had to do the rest. In October 1975, Venera 9 and 10 arrived at Venus and landed as planned. Venera 9 was the first to land. It touched down on a slight slope, a volcanic crater or a hill, and kicked quite a bit of dust while landing. One of its 2 cameras succeeded in photographing and transmitting data, and soon scientists saw the first ever pictures of the surface of Venus. It was mostly sharp rocks, soil, and a distant horizon. The sun was slightly obscured by clouds that day. A gentle breeze was blowing. Overall, it was a pleasant morning. If you didn't pay attention to crushing pressure, almost completely waterless atmosphere, insanely high temperatures, and corrosive acids. Venera 10 landed in the same way a few days later, but the terrain it landed on was much more boring. Just a rolling plain with hardened pieces of magma. Both probes transmitted for 40 to 60 minutes until their orbiters went out of range. When it happened, the temperatures inside the probes were reaching 140 degrees F. The orbiters later burned up in the atmosphere after completing their mission. Venera 11 and 12 could have been a success, but a mysterious electric anomaly messed up with their cameras, so their trip was quickly forgotten. And Venera 13 and 14 entered the picture. They had improved scientific instruments and cameras that could take color images, and new heat-resistant technologies were used during the creation of these probes. Venera 13 arrived first and landed as planned. It took 2 photos, one black and white and the other in color. In the photos, one could see a surface of pebbled, loose soil and outcroppings of bedrock. It all looked pretty similar to the surface of the ocean. In the distance, there were rolling plateaus and an orange sky. The images taken later by Venera 14 showed a more weathered plain with less loose soil and fine-grained rocks. The 2 probes also sent back what they heard. It mostly sounded like a gently blowing wind with hints of distant rumbling. Could be Venus quakes. Venera 13 and 14 were the last landers to touch the surface of the planet. Venera 15 and 16 just flew around Venus, mapping its topography from orbit. On the 30th of May, 2024, scientists made a shocking discovery. A rock that cracked open after NASA's Curiosity Mars rover drove over it revealed yellow sulfur crystals. It was something never seen on the red planet before. Starting from October 2023, Curiosity has been exploring an area rich in sulfates. That's a kind of salt that forms when water evaporates and contains sulfur. But in the past, all discovered rocks only had mixes of sulfur and other materials, while the rock found by the rover is made of pure sulfur. Now, most people associate sulfur with that yucky stench of rotten eggs, but in reality, elemental sulfur doesn't have any smell. It forms pretty rarely and needs very particular conditions. And scientists have never associated such conditions with that very location on the red planet. Now guess what? Curiosity then found an entire field of bright rocks similar to the one it had crashed, made of pure sulfur. Specialists explain that it's something that shouldn't be there. So now, they have to find a way to explain this phenomenon. It's just one of a few interesting findings Curiosity has made during its exploration of the Geddes-Valles Channel. That's a groove running down a slope of 3-mile-tall Mount Sharp. The rover has been ascending the base of this mountain since 2014. Each layer of the mountain represents a certain period of the history of the red planet. And the main mission of Curiosity is to figure out when and where ancient Martian terrain could have provided nutrients for microbial life. Geddes-Valles had been spotted from space years before Curiosity was launched. This channel became one of the main reasons scientists wanted to visit this part of Mars. They believe that the channel might have been carved by flows of liquid water and debris. They supposedly left a ridge of boulders and sediment going 2 miles down the mountslide below the channel. Since Curiosity arrived at the channel earlier this year, researchers have been trying to figure out whether landslides or ancient floodwaters built up the large piles of debris rising from the channel's floor. The latest data from Curiosity hints that both factors played their own roles in this process. Some mounds look as if they were left by wild flows of water and debris, and others seem to result from local landslides. The thing is, stones carried by water flows got rounded like river rocks, and angular rocks are likely to have been deposited by dry avalanches. One more detail: water soaked all the material that settled in that area, and the resulting chemical reactions bleached white halo shapes into some rocks. Over time, wind and sand erosion revealed those shapes. Researchers say that the period when it was all happening wasn't a quiet one for Mars. There was an astonishing amount of activity there. Multiple flows down the channel included severe floods and boulder-rich flows. All this evidence of water tells a more complex story than what scientists expected to find in that region. That's why they've been so eager to lay their hands on a rock sample from the channel. It would let them learn more about the history of that area. Well, on the 18th of June, they got their chance. The sulfur rocks were tiny and brittle, so they couldn't be sampled using the drill. But nearby, Curiosity found a large rock that was later nicknamed Mammoth Lakes. Rover engineers had to look for a part of the rock that could allow safe drilling. Luckily, there was a suitable parking spot on the loose, sloping surface of the rock.
Curiosity bored its 41st hole with the help of a powerful drill. Then, the rover trickled the powderized rock into its belly for further analysis. This way, scientists will be able to figure out what material the rock was made of. Curiosity has already moved away from Mammoth Lakes. Now, the rover is off to search for other surprises the channel has prepared for us Earthlings. Venus is often called Earth's evil twin. The thing is, this world once started off quite similar to our home planet. But later, something went wrong. These days, the two planets are relatively close and similar in size. But Venus's atmosphere is very different from that on our planet, all thanks to a runaway greenhouse effect that has been going on for a long time. The surface of Venus can get even hotter than the surface of Mercury, 864 degrees F. And the surface pressure feels as if you're more than half a mile underwater. The thick atmosphere presents its own challenges. Its clouds consist of sulfuric acid, which is used in lead-acid batteries, as well as industrial cleaners. And if you decided to land on the planet, you'd have to survive atmospheric entry, with friction heating you up to 20,000 degrees F. Still, people have always wanted to explore this inhospitable world, and we can't but talk about the Venera program. During the 1970s and 1980s, several spacecraft studied Venus from orbit and from its hostile surface for an hour or so at a time. The 10 successful Venera landers provided us with most of the data we have today about the surface of this mysterious planet, including surface composition, direct measurements of atmospheric conditions, and sets of unique images. At the same time, astronomers got their hands on these treasures, only after a series of annoying failures. They started with Venera 1, launched in February 1961. Each consequent spacecraft was somehow improved and upgraded. But it still wasn't until the fifth group of Venus-bound space probes launched in 1967 that one of them, Venera 4, reached its target and sent data from Venus. Before that, Venera 2 and 3, launched in November 1965, were supposed to land on Venus, but both of them failed in transit. 11-foot-tall Venera 4 was a hefty thing. Its bottom lander was a bunch of instruments and a battery wrapped up in a pressure shell equipped with a parachute. This probe reached Venus in October 1967 and successfully launched the lander. The mother spaceship sent the probe flying over the planet, and it entered Venus's atmosphere. Temperatures were reaching 20,000 degrees F, and the entry force was as great as 450 G. It didn't prevent the onboard instruments from analyzing the atmosphere and sending back data. The first recorded temperature was 102 degrees F, and atmospheric pressure was similar to that on Earth. But the deeper the probe went, the higher the numbers became. 10 atmospheres, 20. They kept going up much higher than engineers had anticipated. 93 minutes into the mission, when the probe was still more than 16 miles above the surface of the planet, Venera 4 cracked open near its top and crashed. At the crash point, the measurements showed 22 atmospheres and 530 degrees F. Scientists realized that they needed a bigger spaceship. After some intense engineering, Venera 5 and Venera 6 saw the light of the day. Engineers did everything they could to make the landing probe stronger, but they were pressed for time. That's why Venera 5 and 6 were not fully prepared when they went on a mission. That's why Venera 5 transmitted data for a mere 53 minutes before succumbing to temperatures of 600 degrees F and pressures of 27 atmospheres. And Venera 6 lasted for 51 minutes. In any case now, the leaders of the project knew what it would take. 840 degrees F, 100 atmospheres, corrosive acids. They seemed to be prepared. They found new materials to build the probe. They got a hotter and stronger test chamber for the trials. They modified the parachute to make the lander fall faster so that the probe could spend as much time on the surface as possible. The lander was also designed in the shape of an egg and made of titanium, so its surface was smooth and had just a few ports, welds, and substructures. The insides were lined with a shock absorber and insulation layer.
The chamber was also to pre-chill to freezing temperatures before entry. And Venera 7 was finally a success. It reached the planet in December 1970, separated from the mothership, and went down into the atmosphere. The probe transmitted data for 35 minutes, and things seemed smooth. But then, its chute melted, and the probe dropped like a rock, hitting the ground at 35 miles per hour and bouncing. Then, a second after the landing, the signal was abruptly cut. It looked like the probe crashed to bits. Shockingly, a few months later, while looking through all the data they managed to get, engineers rediscovered the signal. It was super weak and lost amidst the noise. Apparently, when Venera 7 bounced, it misaligned the antenna. The probe rested on its side, which weakened the signal to 1 or 3% of its initial strength. The probe kept transmitting data for 23 minutes. After that, the temperatures got too high and melted its shell. Venera 8, launched in 1972, had a similar design and experienced a similar fate. Venera 9 and 10 were a new generation of probes. They could send back black and white photos. It was actually the probe's main goal, to send the first ever photographic panorama from another planet. Venera 9 and 10 were 5 times heavier than their predecessors and weighed 5 tons at launch. The lander was 6.5 feet tall. It was basically a hermetically sealed titanium sphere that was supposed to hold the instruments. It was bolted with gold wire seals. Inside, there were shelves of beryllium and electric fans, whose main goal was to disperse heat to prevent instrument failure. On the bottom of the lander, there was a shock-absorbing ring. And at the top, there was a titanium ring that looked like a hat. It served as an aero brake. The parachute was supposed to detach at 30 miles above the surface, and the aero brake had to do the rest. In October 1975, Venera 9 and 10 arrived at Venus and landed as planned. Venera 9 was the first to land. It touched down on a slight slope, a volcanic crater or a hill, and kicked quite a bit of dust while landing. One of its 2 cameras succeeded in photographing and transmitting data, and soon scientists saw the first ever pictures of the surface of Venus. It was mostly sharp rocks, soil, and a distant horizon. The sun was slightly obscured by clouds that day. A gentle breeze was blowing. Overall, it was a pleasant morning. If you didn't pay attention to crushing pressure, almost completely waterless atmosphere, insanely high temperatures, and corrosive acids. Venera 10 landed in the same way a few days later, but the terrain it landed on was much more boring. Just a rolling plain with hardened pieces of magma. Both probes transmitted for 40 to 60 minutes until their orbiters went out of range. When it happened, the temperatures inside the probes were reaching 140 degrees F. The orbiters later burned up in the atmosphere after completing their mission. Venera 11 and 12 could have been a success, but a mysterious electric anomaly messed up with their cameras, so their trip was quickly forgotten. And Venera 13 and 14 entered the picture. They had improved scientific instruments and cameras that could take color images, and new heat-resistant technologies were used during the creation of these probes. Venera 13 arrived first and landed as planned. It took 2 photos, one black and white and the other in color. In the photos, one could see a surface of pebbled, loose soil and outcroppings of bedrock. It all looked pretty similar to the surface of the ocean. In the distance, there were rolling plateaus and an orange sky. The images taken later by Venera 14 showed a more weathered plain with less loose soil and fine-grained rocks. The 2 probes also sent back what they heard. It mostly sounded like a gently blowing wind with hints of distant rumbling. Could be Venus quakes. Venera 13 and 14 were the last landers to touch the surface of the planet. Venera 15 and 16 just flew around Venus, mapping its topography from orbit.
Long before satellite TV or GPS, NASA made a huge silver balloon to show that global communication via satellite was possible. This was ECHO, the U.S. first communications satellite. We can say that it paved the way for many current communication technologies. It all started when scientists realized that we already had a satellite that could reflect signals. Right, I'm talking about the moon. After a series of tests, they successfully used Earth's natural satellite as a huge reflector to send voice signals from California to New Jersey. They even established a two-way telephone line using the moon as a reflector. But how was it possible? Often in underground car parks or even outside, mirrors are installed at turns with poor visibility. It's an easy way to look around corners. Fundamentally, the same idea has been used for almost the entire history of wireless signal transmission over long distances. Imagine you want to send a signal from one point on the planet to another point on the other side of the globe. The direct signal cannot travel this way. Therefore, you need some mirror, but high in the sky. At first, people used the upper layers of the atmosphere for reflection, but this is tricky and requires a lot of effort. Therefore, scientists decided, why not launch an artificial mirror into orbit? Because just like light bounces off a mirror, radio waves can be reflected too. When some signal bounces off a surface, it spreads out in all directions. A small portion of this signal is bound to make its way back to Earth, and there, it can be picked up by a receiver in a different place. The larger the reflector is, the stronger and more focused signal it will return. But let's get back to Echo. Originally, it wasn't designed to be a communication satellite. Engineers first thought of the balloon as an air density experiment. They believed that the ways to measure air density in the upper atmosphere were insufficient at that time. So they designed a better craft. But later, due to some circumstances, Project Echo turned into a communication relay. Technologically, Echo was rather simple, and it functioned as an enormous mirror in orbit. But to work, it had to be supermassive. Echo 1 was made from a huge sheet of mylar plastic. It was incredibly thin, a mere 1/10 the thickness of a human hair. The sheet itself was cut into more than 100 gores, and each of them was covered with a thin layer of aluminum. That's what gave the balloon its shiny appearance. After that, the gores were glued together, creating the final sphere. Once it was finished, NASA inflated Echo for the first time. The huge balloon came to life in 1958. It was one of the largest things ever launched into space, and the only way to send it into space was to pack it down and inflate it once it was in orbit, and it turned out much more challenging than one could think. Instead of carrying its own air, Echo had small canisters with benzoic acid. That's a special powder that turns directly from a solid to a gas when heated. So when the balloon was released into space, the heat from the sun turned the powder into gas in no time. It all expanded inside the balloon, and in a matter of seconds it was fully inflated. Such a massive object floating in space made it a target for micrometeorites. To protect the balloon from small punctures, engineers supplied it with an extra amount of benzoic acid. It could be released to maintain the balloon's pressure. Echo 2, though, had an even better solution. Its skin was made of mylar too, but it was sandwiched between two huge sheets of aluminum foil. When the balloon was pressurized, the foil stretched, stiffening and hardening in place. It made the balloon become rigid without any additional internal pressure to maintain its shape. Even if micrometeorites hit it, it could still hold its shape. No wonder these giant, shiny things were very visible. For a decade, they were some of the brightest objects in the sky, brighter than the North Star. And this brightness was the key feature of the balloon's design. To send and receive signals, the ground stations had to be able to track the balloons as they moved across the sky. The easiest way was to point the antenna dish directly at the balloons once they were visible. But it was only possible during twilight hours when the sun was illuminating them. When the balloons couldn't be spotted with the unaided eye, they relied on NASA's tracking network, predicting the orbits of the satellites. On Echo 2, there was a tracking beacon. It sent out pulses, which made the balloon easier to track during the day. Most of the project's communication was done between special ground stations in New Jersey and California. At the same time, Echo was supposed to be a global experiment. Thanks to their orbits, the balloons flew over every part of the planet. It allowed transmissions to be done literally anywhere by anyone who had the necessary equipment. One of the cool things about the balloons was that they weren't only used for sending signals around the world. They also helped researchers to accurately measure the shape and size of our planet. You see, at that time, the most accurate measurements relied on a method called star triangulation, and the actual distances between cities and continents could be off by more than 100 miles. So researchers used Echo to figure out the exact location of different points all around the globe. They measured the time a signal needed to travel from two locations, which gave them the precise distance to Echo. After that, by measuring the angle at which Echo appeared in the sky, scientists formed a triangle, being able to calculate the distance between 2 points to within several feet. It made all the calculations 10 times more precise. At that time, though, NASA was still a very young organization, so people working there knew very little about the long-term effects satellites experienced in space. And one of the biggest unknown factors was atmospheric drag. Even at really high altitudes, like 1,000 miles and more, there are tiny traces of atmosphere that can slow down objects. Imagine trying to walk through waist-deep water. The water will resist your movements and make it harder to move forward. The same happens with spacecraft. They push on the air, and the air pushes back in the opposite direction. The denser the atmosphere a spacecraft is traveling through, the greater amount of drag it experiences. It allows researchers to estimate atmospheric density by measuring how drag changes the orbit of a satellite. Echo's had a large surface area to mass ratio, so the balloons felt the effects of drag more than any other satellite. Observing Echo 1, NASA managed to track how its orbit changed over a few years, and it was a lot. Strangely, it wasn't atmospheric drag that had altered it. Solar wind radiating from the sun was to blame. It was pushing Echo 1 toward Earth. The balloons kept working perfectly well throughout the 60s. They proved that a global communication system in space was possible. Plus, they gave rise to many new techniques and technologies. For example, the first balloons spawned other satelloons, a combination of satellites and balloons. Echo 2 also fulfilled the original purpose of measuring air density and solar radiation. Echos's metallized plastic helped scientists evaluate the use and long-term durability of similar materials for other spacecraft. By the mid-60s, active communication satellites had become a more effective solution than passive systems like Echo. With the help of a passive system, the transmitted signal had to be strong enough to travel all the way into orbit and back. And with an active system, the signal only needs to be strong enough to travel all the way up there to the satellite, which then gives it power for the return trip. In any case, during their mission, the iconic balloons showed us even more than we could have imagined. Afterward, the receiver that was used to detect Echo's signals continued its work, as well as other materials used for the Echo project. They are still used in different spacecraft. It is assumed that there is a supermassive black hole at the center of every galaxy in our universe. These space monsters have been discovered in the centers of many galaxies, and our Milky Way is no exception. There is Sagittarius A at its center, a supermassive black hole surrounded by a hot, radio-emitting, accreting gas cloud. To accrete means to absorb matter from the surrounding space under the influence of gravitational forces. In the case of black holes, the attraction is incredibly strong. As a result, the radiation surrounding them is also immensely powerful. Observations made by the Event Horizon Telescope in 2022 made it possible to simulate this substance in our galaxy. From these observations, astronomers were able to estimate the mass of the black hole. It turned out to be 1 million solar masses, which is about 1 million times less than the mass of the entire Milky Way galaxy. So, 1/1,000,000th of the mass of our galaxy is that supermassive black hole at its center. Such a ratio of the mass of the entire galaxy to the mass of the black hole at its center is characteristic of many observations. Moreover, the value of this ratio is reproduced within the framework of modern models. Now, let's discuss two hypotheses for the formation of supermassive black holes. The first model speaks about the creation of small seeds that describe the gradual increase in the mass of a black hole, the accretion of matter into a stellar mass black hole. The second model suggests that supermassive black holes form when large gas clouds collapse. In this case, the collapse occurs bypassing the stage of a supernova explosion, in which the explosion would scatter most of the mass, preventing the formation of a supermassive black hole. In any case, conceptually, such a process can be described this way. There's matter in some compact area, which is the seed for the growth and development of a black hole. Black holes accrete matter around them and their mass increases. It is important that the evolution of black holes is a temporary process that scientists want to study in dynamics. But how can one see evolution that takes place over millions or even billions of years? Unfortunately, or fortunately, light from a distant galaxy takes time to reach us. That's why if we look at very distant objects, we will see them as they were in the past due to the propagation delay of light. But to look far into the past, one needs to look at very distant objects. The light from them is very difficult to observe experimentally. The good news is that with the launch of the ultra-precise James Webb Space Telescope, scientists can study even faint signals from galaxies that formed when the universe was about 1 billion years old. That is, looking back almost 14 billion years. One of the most surprising results obtained from James Webb is the discovery of a lot of galaxies within 2 billions of years of life of the universe. These galaxies have active galactic nuclei, faint compact regions at the centers of galaxies, emitting large amounts of energy. Here, the Space Telescope shows its power. These active galactic nuclei have luminosity that are thousands of times lower than the luminosity of quasars detected in ground-based studies. They appear red because they are dusty. The dust obscures black holes and reddens the colors, so they're called little red dots. What is very important, their masses lie between 10 and 100 million solar masses. Surprisingly, using very advanced analysis methods, scientists can estimate the mass of a black hole at the center of a little red dot. It turns out that it reaches millions of solar masses. It means that the mass of a black hole at the center of such a little red dot is only several orders of magnitude less than the mass of an entire galaxy. I'll remind you that the supermassive hole at the center of our galaxy is millions of times smaller than the mass of the entire universe. Thus, the ratio of the mass of supermassive black holes at the centers of such galaxies to the mass of the entire galaxy is phenomenally large. But explaining this fact will be a difficult problem for current models of black hole evolution. One of the hypotheses that scientists are now working on is that it's not a black hole that forms from a seed at the center of a galaxy, as we discussed earlier. It's a galaxy that forms around the already created black hole. Such black holes are called primordial black holes. This is a hypothetical type of black hole that was formed not due to the gravitational collapse of a large star, but in superdense matter during the initial expansion of the universe. If it turns out that these primordial black holes do exist, it will open up a new window for dark matter models. But this is a topic for another video. Recently, an international team of astronomers has used the James Webb Space Telescope to find evidence for an ongoing merger of two galaxies and their massive black holes, and it happened when the universe was a mere 740 million years old. The double black hole system is known as ZS7. This is the most distant detection of a black hole merger ever. Plus, it's the first instance of such a phenomenon detected so early in the universe. But let's look into the details. astronomers have been locating different supermassive black holes with masses of millions to billions of times the mass of the Sun, situated in the most massive galaxies in the local universe, including our home Milky Way galaxy. Those giant black holes most likely had an immense impact on the evolution of the galaxies where they dwell. At the same time, scientists don't fully understand how those objects got to be so massive. The discovery of such monstrous, fully formed black holes means that their growth occurred very quickly and very early. Massive black holes that are actively accreting matter have special features that allow astronomers to detect them. These features are usually not visible from the ground, but can be observed with the help of James Webb. So, researchers found evidence for very dense gas clouds with rapid motions close to the resulting giant black hole. Plus, they detected hot and highly ionized gas illuminated by energetic radiation, like the one typically produced by black holes in their accretion periods. With the incredible sharpness of the telescope's imaging capabilities, scientists also managed to spatially separate the two black holes. One of these holes has a mass that is 50 million times the mass of the Sun. The mass of the other black hole is likely to be similar, but it's much more difficult to measure it since this second hole is surrounded by a thick cloud of gas. These findings suggest that mergers are a crucial way through which black holes can grow extremely fast, and they could do it already at cosmic dawn. After analyzing other Webb's findings of active massive black holes in the distant universe, researchers have come to the conclusion that massive black holes have been influencing the evolution of galaxies from the very beginning. Once the two black holes merge completely, they will also generate gravitational waves. Such events are supposed to be detected by the next generation of gravitational wave observatories, such as the upcoming Laser Interferometer Space Antenna, aka LISA, mission. It has been recently approved by the European Space Agency. This mission will be the first space-based observatory dedicated to studying gravitational waves. The results we get from James Webb tell us that lighter systems detectable by LISA might be more frequent than we used to think. It will likely make researchers adjust their models for LISA rates in a similar mass range. Currently, astronomers are planning to study in detail the relationship between massive black holes and their host galaxies in the first billion years. An important part of this program is systematic search for and characterization of black hole mergers. It will help us determine the rate at which black hole merging occurs in the early universe. Plus, with the help of this research, we can figure out the rate at which gravitational waves have been produced from the dawn of time.
Before J. Robert Oppenheimer ended up as the leader of the Manhattan Project, he was one of scientists studying nuclear physics under some of the most extreme conditions you can only imagine. By that, I mean the gravitational collapse of the most massive stars in the universe. Oppenheimer was part of the first team ever to determine the upper bound to the mass of cold, non-rotating neutron stars. Stars more massive than that limit collapse into a black hole. A star is an enormous collection of mass, dominated by hydrogen and a substantial fraction of helium, as well as some amounts of other elements. Its ginormous force of gravity works non-stop to pull all that mass inward. And the question here is, why don't such objects gravitationally collapse? For example, a star like our Sun has around 300,000 the mass of Earth. At the same time, it's only about 1/4 as dense as our planet. There must be some kind of internal force generated within the star itself and pushing back against gravitation. Scientists have been studying stellar evolution for many years. And here's the basic picture. In the majority of stars, pressure comes from thermonuclear reactions, due to which stars glow. In thermonuclear reactions, light elements are converted into heavier ones, and energy is released. When a star is running out of light elements, it has two options: to become a red giant and then a white dwarf, or to explode as a supernova and then become a neutron star or black hole. Most astronomers eventually came to the conclusion that under the extreme pressures and temperatures, a series of nuclear reactions could occur leading to hydrogen nuclei getting converted into helium nuclei, releasing energy in the process. This released energy would provide huge amounts of outward radiation pressure, allowing most stars to shine for extremely long periods of time and holding them up against gravitational collapse. But unlike most scientists working on this problem, Oppenheimer was more interested in another aspect. What would happen to a star when it eventually exhausted its nuclear fuel it was burning to hold itself up against gravitational collapse? The scientists knew that without a source of fuel within a star, gravitation would gain the upper hand, and the core of the star would start contracting. There wouldn't be enough time for heat to be exchanged between the interior and exterior environments, and the same amount of heat would get compressed into an increasingly smaller volume. Today, we know that increasing the temperature of the helium-rich core of a giant star will release more energy than fusing hydrogen into helium, and stars as massive as the Sun eventually initiate helium fusion. But what happens when a star runs out of helium fuel in its core? Eventually, it'll stop emitting radiation too. The core will begin to contract, heating it up even more. Some stars, like the Sun, can't heat up enough to start any further nuclear burning reaction. So the core, mostly made of such elements as carbon and oxygen, contracts and contracts until there's no way to do it further. After all, there's a limit to how far a star can contract, and it's set not by the thermal radiation pressure of a living star, but by a certain quantum mechanical effect. No two electrons, an example of a type of particle known as a fermion, can occupy the same quantum state. That's why such types of stellar remains can hold themselves up against gravitational collapse. These remnants are physical objects nowadays known as white dwarfs, with higher temperatures and densities at their cores than at the exteriors. Still, there must be a limit to how massive a white dwarf can be. Beyond a certain mass, the size of this space object might be predicted to collapse to zero. Once a critical density is reached, either further nuclear reactions must take place, or a white dwarf must collapse further, which might lead to the appearance of a black hole. Oppenheimer chose to dwell on a different aspect of the problem, though. He asked, what would happen to the most massive stars, those whose temperatures and densities rose to unbelievable heights after they had burned through both their hydrogen and helium fuel sources? When a massive enough carbon core of a star contracts, it becomes so hot it can initiate carbon fusion, which leads to the creation of such elements as neon. As the neon core contracts and heats up, the burning of this element occurs at even higher temperatures. Eventually, it gets blasted apart by high-energy photons into oxygen. The core contracts and rises in temperature again, which leads to oxygen fusion and the production of such elements as silicon and sulfur. After exhausting all its oxygen, the core contracts even further, and silicon burning occurs. Sulfur, argon, calcium, iron, titanium, chromium, and nickel start building up, and the core becomes inert. A core collapse supernova follows soon. At that time, Oppenheimer didn't know such details, but he still came to an important realization. Any nuclear reaction would eventually run into a limit. The limit of having the entire core of a star behave as one single atomic nucleus. That nucleus would also have a limit of how massive it could be. If you compress a proton and an electron under high enough pressure and temperature, it will turn into a neutron through the process of electron capture. Oppenheimer's calculations were based on the Pauli exclusion principle. What is it? There are two types of particles. Bosons can be compared to extroverts. Imagine that you need to accommodate a lot of people in a hotel. Extroverts can be accommodated in a hostel. It will be fun, and they won't mind being cramped up there. But fermions are like introverts. If each room is a separate quantum state, then two electrons cannot live together. They need to be housed one at a time. This is the Pauli exclusion principle. Fermions, very roughly speaking, repulse each other. And this repulsion keeps the final stages of stellar evolution from collapse. Take a neutron star, compress it further, add some mass to it, and decrease its volume. At one point, you'll hit the same limit white dwarfs have. Oppenheimer reasoned that the same physical effects could come into play here. Whether you have a group of protons, neutrons, or electrons doesn't matter. They're all examples of fermions and obey the same principle. No two of them can occupy the same quantum state. This creates a pressure that pushes outward, preventing the stellar remnant, be it a white dwarf or a neutron star, from exceeding a certain critical value for its mass. The equation for that maximum mass value for the simplest model of a neutron star, cold and non-rotating, was first created by Oppenheimer and Volkoff. Today, it's known as the Tolman-Oppenheimer-Volkoff limit. According to it, the maximum possible mass for a non-rotating neutron star is somewhere around 2.2 to 2.9 solar masses. How do modern-day predictions that developed out of Oppenheimer's work stack up to the observations we have for neutron stars? Actually, very well. For example, the most massive neutron star with accurate distance and mass measurements is this millisecond pulsar. Although it rotates rapidly, it has a mass of 2.08 solar masses. In 2017, astronomers saw the first merger of two neutron stars ever. The combined mass of the stars taking part in the merger was around 2.75 solar masses. Those stars briefly formed a neutron star before collapsing into a black hole. And finally, in 2019, the second merger of two neutron stars was observed. But in this case, the combined mass of the two stars was around 3.3 to 3.7 solar masses. This time, the post-merger remnant turned straight into a black hole with no neutron star intermediary. It's a tricky feat to find the highest mass neutron star and the lowest mass black hole, since figuring out the properties of these objects is very difficult due to the fact that they're relatively rare. Plus, they're mostly located thousands of light years away from us and aren't known for being bright. Still, with constantly improving pulsar timing technology, the discovery of new neutron stars within the Milky Way, as well as neutron star mergers, sounds more realistic. Soon, we might discover where the neutron star / black hole mass limit lies. As for Oppenheimer, his most lasting contribution to the world might be developing a method for theoretically understanding the upper mass limit that defines the boundary between a black hole and a